that much clicking there. So are we ready?
Yeah, I just hit the record button, and whoever edits it can edit it out, and all the other noise.
Okay, yeah, in that case, yeah. So the other Doug will have to edit, I guess. I assume you're going to send it to Carl, Doug. Okay. So Doug, the other Doug, do you want to do the announcement of the slides or should I? Okay, he's on mute. Okay, well, I get.
John, you just put mute.
Hey, you just muted yourself, John.
Sorry, that was me. I put John on mute. That was my mistake.
Right, but I can mute. I'm sort of the charge of this thing right now. So I will start. Welcome everybody to the DPRG Tuesday meeting. We tend to discuss robots related stuff. We were formed in 1984, and we meet every Tuesday night and second Saturday of the month. These are some of our sponsors. Our upcoming plans for next month will be Dave Anderson and making a map, a navigation map. So with that, I will pass it on to Doug. So Doug,
Okay.
take it away.
So I have been working on my telepresence robot and the DPRG API, and I hope the camera is pointing at the two different robots on the floor right now. And the little car lit up is the one that I've been using to demonstrate with, and the other one is the base of the Roby Senior. And what I wanted to demonstrate tonight was moving the pie from one to the other and showing that it would, sorry, I'm busy presenting here, showing that it would be able to do the, respond to the ABI on both robots without any programming changes. And so let me hop over here, present something more interesting than that. Hopefully at this point you see the control panel to the robot and the video feed from the robot. Anybody?
Yes.
Okay, so this robot is the little car, and you see that you can click and it moves, and that's all fun. And now let me get off of presenting here because I couldn't get my little phone to work this time like it did last time. So this time I'm going to set this down. Hopefully you can kind of see what I'm doing. I'm going to take the Arduino, which is the brains, off of the little car, pick up the camera, and I have to move the power pack because I only have the one power pack for my Arduino right now. So once again, I'm not making any changes to the programming of the Pi, which is the brains, and which is using the API that we created. And let's see. Plugging power into the Arduino. On. Plugging the Pi into the Arduino. And sometimes What you're hearing now is huh. Well, that was a failed response. Let me get back over to my screen again.
Was all that noise just the motors running?
That was the motors running. It's a very noisy motor system. And now I'm back. Basically, it failed because it turned the motors on before I told it to. And it didn't do that 5 minutes ago when I was testing it. So God only knows what I did wrong this time. Probably it was the serial port. When you change the serial port from one computer to another, it tends to do that. So I'll have a better demonstration next week. I kind of wanted Carl to see this anyway because he was a big proponent of this API business. So if anybody's got any questions, I can answer them, but it was not much of a demo.
Well, it's an
For
interesting
those of us
concept.
who are, oh, go ahead.
Well, it's an interesting concept, at least. I'm wondering, you said maybe it's a serial port. But
Yeah, when you plug the serial in, sometimes it goes from ACM0 to ACM1. So I was transmitting data from the Pi to the Arduino over serial. It may have been ignoring me.
I was just going to point out to those of us who are old enough to remember robots from the 1970s, all of the motors were at least at 90 to 100 decibels each, and everything was very loud, and now it's a lot quieter.
Yes. Roby has some really loud motors. I'm actually thinking about, I've been busy refurbishing him so that he can run around the house and be one of my robots that just kind of roams the house. But he's so noisy and the dog hates him. I may rebuild the base unit with new motors. And also I'm upgrading I've got 4 of the ultrasonic sensors on it. And Chris was saying he can hear them things, so I'm sure the dog can't. That's probably part of what drives him nuts. I'm going to switch to
My dog does not respond to my robot other than trying to chase it, but it doesn't seem to be bothered by the sensors for some reason.
Oh, really?
Yeah.
Mine may just hate robots. I don't know, but if he sees a robot, he attacks a robot.
We've met your dog.
Yes.
Yeah. Out of curiosity, Doug, I mean, you could actually just measure the diameter of those motors, and probably if they're 22 or 25 or any kind of a standard diameter, you can probably swap out some modern, less noisy motors right in there. And just
I
change
think
the
I could, but I think the noise is actually from the gearing mechanism.
That's what I was going to say. I think it's probably the gearing.
But you might be able to look down on those plastic gears there, and I think they're the real culprits.
Mm-hmm. Then you're stuck with it.
Yes, or just get another base.
I mean, you might make them. You might can make them a little quad if you throw some goopy crap in there.
Ah, that's true.
You might be able to make them a little quieter, but then it might get messy. So
yeah. Well, I'm going to finish refurbishing just because I want to, but I may, after I finish with that, change the base to make it better. But then, getting on to the real telepresence robot, these are just prototypes. And I've got over here a bucket full of parts because John had an Instructable that showed how to make a telepresence robot with that. And I'm going to be using that in the near future to make the production version of the telepresence robot. So we can take it down to Messerspace, and the other John can help me test it in Makerspace. I did have one minor problem. These wheels, which you can tell are pretty big because like side of my face, what you can't tell in the video is they're also pretty heavy. And I got those continuous servo motors. I don't think they're going to be able to handle these wheels. So I may yet go get another version of wheels. The last one I got was from the Roomba. They were Roomba wheels, and I didn't read the stuff very much. They're about the size of a $50. So that was some pretty low clearance. So third type of wheel might work. I found Hobbytown yesterday, so they had plenty of RC car wheels I can play with.
And all else fail, we could print them out
Well,
things
I
like
might be able to find somebody that does pay for the whatever that uses.
so yeah, holler if you can't figure out the reel, because there's one or two that I know of I have downloaded, so it could print.
I don't know if anybody's got a feel for when we're actually going to start up the live meetings again. I'm trying to get this telepresence robot operational before that. And also thinking about demonstrating it at the Seattle thing in July, I think.
Right now, the key would be is you can go to the maker space, and they've had some groups there actually, but right now, people that are there are supposed to wear masks. Now, whether or not that will change as of our governor thing,
Yeah.
even though I personally think it's a little too early. I mean, it's always better to have more than less. So
Yeah.
at this stage, I'm concerned that roughly 45% of the population in the state has been vaccinated. It's not really a good number. But as one person pointed out, the people that aren't getting vaccinated are the ones that are getting sick and are in the hospital. So So
And the company says you don't have to, doesn't mean you can't.
Right. And that's why I said, yeah, it's the key. So back to the subject of robots though.
I think
so holler if you need me to print out the reels, and then we can figure out a time to test or that.
Okay. So I turn it over to Murray. He had an announcement to make.
Oh yeah, just a very brief one. I'm happy to say that we now have over 50 members in our personal robotics Discord channel. And anyone who emails me or contacts me in any way, I can send an invite. They last 7 days. It's a URL. We'd happy to have anybody from the DPRG or the Seattle group. Donna has joined. And we get young people coming in pretty much every day asking questions now. So be happy to have anybody in this group on board. That was it.
So Merle, do you have anything else besides the announcement? Do you want
I can announce, I can post progress is that I'm just pulling it out of the box now. I have received another shipment in the mail, and I have a Zumo. I have now put together in a very different configuration with lots of wires hanging off of it. And I managed to get the encoders underneath through the bottom. Quite a challenge. This thing is very tiny, and it's not designed to be extended. And I got my Arduino Leonardo yesterday, and I just was unsoldering the barrel connector because, unfortunately, if you use the solder proto areas on this at all, you run into all sorts of problems with space. So now the Arduino can't fit on top properly. The barrel connector was the problem. But it's obviously going to be programmed in C++, which is not my favorite language. And so yesterday I also got a Kiktronic robot board, and that is a RP2040 board, so it can be programmed in Python or actually MicroPython. And I'm kind of teaming up with one of the guys I met in the personal robotics group. And he's a math teacher, I believe, somewhere in the Northeast U.S. I think he's a Russian guy, actually, and named Alexander. And he is actually in the process of prototyping a robotics power board in Fusion 360. So I now have a copy of Fusion 360 on my computer as well. And I've offered to do the silk screening on his board and sort of cooperate in maybe he's going to do the board design, and I'm kind of providing advice on what I think might be on that board. But it would be a RP2040 itsy bitsy format or itsy bitsy form factor, programmable in either C++ or MicroPython or CircuitPython. And it would be a board that would fit on top of a Zumo with the idea that it could possibly be a club robot. So that's kind of where we're heading. That's it. Who's next, John?
Well, I could go. Or Pat can go.
I've got just a small update. I don't know if you guys can see that. I got some pulleys and belts. So I will be, after the next 2 weeks, I'll be starting to go back to the robot build. Unfortunately, I'm going away Thursday for a week up north. So way up north in Northern Ontario. Well, I'm going farther north. And I'm on a project install for a week. So I'll miss next Tuesday's meeting. But looking forward to coming back. And by then, I've got a few parts coming in on Amazon. And I should be able to put the robot drivetrain back together.
Dad, I'm really surprised there's anything north of you.
Oh, God. Lots north of me.
Just moose, right?
I saw 2 moose on the last week. I was driving up there. I saw 2 moose off the highway. Saw a rabbit in a bush. All sorts of critters. My brother-in-law saw a bunch of bears the day after we left.
This is much better than any moose on the highway, by the way.
Well, I had to stop.
Oh.
So he crossed from the oncoming lane. He crossed over into my lane. I had to come to a complete stop. He was about 200 feet ahead of me. And so just let him go about his business. He's bigger than I'm driving a truck, and he's bigger than me. So.
Yeah, he's gonna win that. He's gonna win that kinetic battle right there. There's no doubt about that.
100%.
Is moose the plural of moose?
Yes. And one of the problems with moose is because their legs are so long, typically car accidents kill people because their bodies come into the windshield.
They tend to live in the front seat once you hit them.
Yeah. Or die in the front seat, but yeah.
Yeah.
We thank God don't have moose in New Zealand.
Yeah, when you hit the 1,800 pounds, you're not going to win. Like you say, you've got 4.5-foot spindly legs there.
Yeah, the sheep just kind of bounce off your cars in New Zealand, right?
Exactly, yeah. We don't actually. There's Australian possums here, which are eating our forests, and it's sort of a challenge for all New Zealand drivers to hit as many possums as possible. So we get a lot of them on the roads. They're an endangered species in Australia, and here they're like the worst thing you've ever, and they have this kind of sound they make at night.
Don't you also get those big invasions of crabs that give you flats when they cross the road?
But if you go to the doctor, they can solve that problem.
I thought it was Australia or New Zealand where they had the periodic invasion of these really big crabs. They get out on the highway, and when their shells are so hard that they puncture tires.
That sounds very much like an Australian problem. Pretty much everything living in Australia is toxic or dangerous.
Yeah.
On the other note for robotics, I've been doing some calculations on an outdoor rover for the Robo Columbus. I'm at a 67 to 70 pounds. I'm trying to shed weight. So I'm looking at different options, different drivetrains, what I can do. And that's with a lighter battery. Wow, it's a lot, yeah.
So is
And
it
it
a
can be
tank or
repurposed
is it
into something that
wheels?
can move a snowplow.
So is it a tank or do you have wheels on or how
I got
wide
4
will
wheels.
that be?
4 10-inch wheels.
Wooden platform?
That's what I'm working on because wood is lighter than steel, or it's lighter than steel and cheaper than aluminum to make.
Ah,
And he has all those trees up there, so yeah.
No lack of trees. Although I'm not sure, it may be cheaper to use aluminum.
Well, and strength to weight aluminum works pretty well.
It does. It's just it's a lot easier to just cut out another piece of plywood and modify something than it is to go out and get the welder to weld something back together or bolt it back together.
Pat, how big is your battery and what are your expected power needs and for how long?
So I would like to have 2 hours of battery time. and I'm not going to do it with anything I've looked at so far. I may have to go down the road of lithium to get it light enough to be able to do that.
What kind of current?
Right now, I'm looking at probably about 5 amps a motor.
12 volts?
At 12 volts.
So 60 watts?
Yeah. So 60 to, let's say, 100 watts. So I did find a 100 watt hour battery that was 2.9 pounds at 12 volts. Lithium iron phosphate, but I don't think it's going to be enough if I have to run a contest more than once. So that's where I was looking at a larger one that's 200 and I think it's 260 watt hours. But,
And you have 2 motors, right?
yeah, that's 2 motors. So doing the math on it, it's no use starting to build if I can't keep it running. So lead acid would be the way to go. I can get more energy density out of it, but the weight is the killer. It's over 40 pounds for a battery.
And you want the battery to be permanently installed. That is, you don't want to have to swap out batteries.
No, that is something that is optional as well. It's just, if it comes down to a cost of having to swap out a battery, I would prefer it not to be a $200 battery. I actually had toyed with the idea of, instead of a battery, is to put a generator on it. So to put a little 600 watt generator, gas generator.
Why not a little nuclear, like the Voyager?
I let my nuclear scientist license lapse.
Electrolyzer. Well, you know, I've got here lithium-ion batteries that are 5,000 milliamps, so that says they can deliver 5 amps for an hour, and they're quite small and light. And if you were willing to swap it out, you know, an hour's quite a bit of runtime for a contest that's going to take maybe outside 15 minutes or something.
Well,
But that's only half an hour, right? Because 2 motors.
Ah, you mean that's not the total?
yeah, no, that's not the total.
I see. So the total is not 5 amps, it's 10 amps.
So let's say it's going to be approximately 10 amps for 2 motors. Let's say that's an average current, because it'll peak higher than that, and it'll, you know, depending what it's doing.
That's just a shitload of current, you know.
Like I say, I'm working on projects to dump 6.5 megawatts per an hour. So
Well, the outdoor robot I have draws max about 3 amps, but when it's just running, you know, at cruising speed in a straight line, it draws about 300 milliamps.
okay,
So the batteries I've got 2 10-cell nickel metal hydride packs, and I can run 4 or 5 hours on that.
so I'd be curious if I can get the current down to be able, like I say, it's more than one purpose for this robot as well. It's not just to run a contest; it's to plow a driveway or cut the grass or something like that.
You know who draws that kind of amperage are the BattleBot guys. You might look at some of their hardware, and they have special purpose.
They're into hundreds of amps.
Yeah. And
They're also at the hundreds of pounds.
they only care about running for like 10 minutes and they're done. So they got a whole different set of problems.
Yeah, so I'm like I say, if I can drop the current on the motors, that would be great, and you know, be able to run for hours as opposed to an hour.
Well, batteries is exactly what I wanted to talk about. So whenever y'all are done, I got some stuff to talk.
I'm done. Go ahead.
Okay. Let me see if I can figure out how to present here. I made up a thing last week. I showed you all the battery pack that I built, and Carl thought that a lot of people would be interested in knowing more about that and everything. So I wrote something up. Let's see if I can do this. No, not that way.
Yeah.
I'll stop that.
While we're
It should be
waiting,
the button on the far
This one.
right side says percent now.
My entire screen. Okay. You must grant permissions in order to stream.
yet.
How do I grant permissions?
there should be an OK button there somewhere.
Oops. All right. Present now. My entire screen.
Click on the screen and then say,
Dang it. Okay. Well, here. I will,
we can pin you, and that's almost the same thing.
okay. Sure.
Or else have it, if it's in a separate window, click on that window that have the item in.
All right. Well, here, I'll tell you what. I got, I'll put the link over here in the chat to the thing that the document that I made up. And then if anybody wants to download it, you can download it. And I'll just talk about it here. The first thing that was, talking about the things. So we're, just a second.
Okay, well, I have it presented for you.
Perfect.
So tell me if I need to scroll over that.
Nope, that's we can work with that. That isn't clever.
Click on the later button.
But so anyway, okay, yeah, perfect. Thank you. Just this is about lithium-ion batteries, and I think lithium polymers are pretty much the same, just with slightly different characteristics. I'm not sure about the lithium iron phosphate batteries, but so to start with, just with charging them, your chargers have to have a two-stage mode. First is a constant current, and then once the battery gets up to just about its full voltage, then it switches over to a constant voltage. And I'm sorry if most of y'all know this or not. I was just trying to get basic with it. And then once the current drops off to a certain percentage of the original current, it'll trip to stop charging the battery. You don't want to use just a regular constant voltage because you won't get the proper cutoff with a lithium battery, which is bad. It can go into thermal runaway then. And I put the link here to on a Battery University that talks a whole lot about charging, and I just pulled this one picture from them. All right, if you could scroll down a little bit.
So Ian,
Yeah.
excuse me, before you scroll there, Ian, basically the operation of the device is controlled by the current in both cases. That is, there's a constant current until you see the voltage reach a certain point, and then the current.
You'll have a constant current, and that's set by the charger. I've got some small charging modules that they came by default. They charged at 1 amp at 4.2 volts, or for a 4.2 volts battery single cell, but changed out the little resistor that controls that so that they charge at, I think, 780 milliamps until it hits the constant voltage stage, and then of course the current starts dropping off, and it holds it at 4.2 volts for a while until it's done. And it's the same thing if you have batteries in series. So like the pack that I showed y'all last week was three sets of cells in series, so it basically get a 12 volt pack. So I've got a charger that holds at a constant 3 amps until it gets to just about 12.6 volts, and then it switches over to the constant voltage stage.
Does the constant voltage, is it just when you trip that point, or does that have to be measured for a period of time?
No, it's when it trips that point. Some of the better chargers will have a timer where if the battery just takes more than its timer to come to a full charge, then it'll just stop charging. And some batteries, once they start going bad, they start acting funny and don't take a charge right, and the charger can't really tell when it hits that point, and so it'll stop after a certain. Like I said, the better chargers will stop after a certain amount of time. Like I think Murray had that D6 charger that he showed last week, the hobby charger. I'm pretty sure that will do that.
I think I should.
That wasn't me.
So, okay.
So basically, the current is falling because the voltage is held constant, and the current falls as the battery charges. All right.
Right. So,
All right. Sorry, I'm a little slow. Thank you.
No problem. In the constant current stage, the volt is going to hold a constant current, and the voltage is going to continue to climb. And then once it gets to its 4.2 volts, then it's going to switch over and it's going to hold it straight at 4.2 volts, and then the current will drop down as the battery continues its charge.
So that probably doesn't really go to zero, right?
No, it won't go to zero. I think the small chargers that I have, the small modules that I have, go to 10% of. It's either 10% or 3% of the constant current amount. So if it's 780 milliamps, I think that it goes down to once it gets down to like below 7.8 milliamps, then it cuts off. Because with lithium batteries, you can't trickle charge them. That's quite damaging to them.
Thanks.
Yeah, no problem. So the second thing that I have here is the BMS, which is a battery management system. And let me see if y'all can see in this pack that I have here. I don't know if you can see my face, or if you can only see the screen there. But I got the circuit board on the battery pack, and what that will do is you wire up your power in, and then from the junction of each cell goes to another portion of that circuit, and so it can monitor the voltage of each set of each bank of cells independently. And what it'll do is when you're charging, now it doesn't have a charging circuit, so it doesn't provide that constant current and then constant voltage switchover, so you still have to have a proper lithium charger. But what this will do is it'll monitor the voltage of each cell, and once a bank of cells gets to its 4.2 volts, it'll put a resistor in parallel with that set of cells to stop it from charging, so that the rest of the cells can catch up to the same voltage. So it balances all of your cells that are in series. And because of course, if you get out of balance, and you have no way of knowing it, you could have one set of cells that could be a lot lower than the other one. So when you go to charge them, you'll have while that set of cells is trying to charge to your full 4.2 volts, your another set of cells might be charging to 4.3, 4.4, and then fires happen. So it's and that battery management system also provides, or this particular one will provide overcharge protection, over discharge protection, reverse voltage protection, and I think something else. I can't remember what else, but and the balance charging thing. And I put some links in here just to various different BMS modules that I found on Amazon. There's some for 3S battery pack would be 3 sets of cells in series. I think there's one for a 2S, and I think one for maybe like a 5 or 5S or something. But even with the battery management, you still need, like I said, a separate proper lithium charger. And there's a lot of videos that I've found out there that will talk about the battery management system, and the guys will just hook a straight 12.6 volts up to it from a power supply, and you're like, oh, it's fine, but it's really not. So that's one thing to be aware of if go looking into it, is there's a lot of bad information out there too.
Well, I'll tell you how cheap, because I got a lot of railroad batteries that won't charge anymore because one cell goes extremely low. So I just crack them open. I got a bunch of the safety notes, and I apply a charge to them enough to get them to enough voltage so that then the protect circuit will take over, and I'll be able to charge them. I do that to these batteries a lot. But
yeah, you can do that. I haven't been brave enough to do it myself yet, though.
I guess you might want to call it a manual balance of the thing. They're not truly balanced, but they're balanced enough to allow the protect circuit to allow the normal charger to do what it wants to do.
Right.
Yeah.
And wow, this went a lot faster than I expected it to. Let's see. So I guess the next part here is testing cells. I went in this particular battery pack that I showed you here. I actually scavenged all of those cells out of old laptop batteries, and because usually when a laptop battery goes bad, it'll just be one set of cells that has gone bad, and then the other 4 or other 6 cells will still be good. And so I've scavenged quite a bit. But there's a lot of testing that you have to do when you go that way, because you gotta fully charge them, and then you've got to discharge them at a constant rate, and so you can measure what the capacity is, and then you also have to check for the internal resistance, make sure that they're similar. And I put this link here to this dude Julian Eilert. I don't know if any of y'all have watched any of his videos. But he does a really in-depth description of how to test for the internal resistance of lithium-ion batteries. And I don't think that's a very long video. It's pretty quick, but it's pretty detailed for what it is. And then this last part here, the pack building is you make when you don't want to solder the lithium batteries like directly to the cells, because you're just introducing way too much heat for too long a period of time to get a good solder joint. So that's just a bad idea. So you want to, if you're going to build your own battery packs, you really want to use a spot welder to weld the nickel strips to the cells. And I got a link here to a video that I found that was a really neat, inexpensive handheld battery powered one. And what you call it? And then I got a link to to that one on Amazon. And then I think I might have some more down at the bottom. You can scroll down a little bit more. No, that was it. I thought that maybe scroll up a little. So I thought that I put another link on here. Go up a little bit. Lithium-ion phosphate chargers. Oh, okay. There's some links to some different battery chargers. Go up a little bit more, please. A little bit further. Oh, there it is. Where it says Lee Wright Ultimate BMS Video. This dude makes electric skateboards, and this is actually quite a long video. It's about a half hour long. But he really goes in depth explaining how the BMS modules work, and various things to take into consideration, and how to wire them up and everything. Probably most of that video won't really pertain to you guys, or well, us guys, but when he starts talking about how the BMSs work is really kind of interesting if you want to look at making your own battery packs. So I think that's about all I got. If anybody has any other questions.
That's really useful. Thank you.
All right, cool. Continue on then.
Back in the before time when Mike's Hobby was still here, if I needed battery packs, I went down and I talked to Mike, and he had one of his guys make them up. And they, did it all the time and were real good at it. And so I haven't gotten bold enough to try making any myself.
Well, speaking of sort of before times, I had an occasion to go over to Wild Bill's in Irving, which is now a hobby town, right? And it's been a long time since I've been over there, and they have a couple of outdoor tracks. They say it costs $5 a driver to go out there and spend all day. He says, but most of the time we just tell you to go out there. If it's not really busy and all that kind of stuff. Well, one of them's a kind of a dirt oval track, and the other one's got gravel and rocks and all kinds of manner of things to try to crawl over and do stuff. I'll probably take a trip down there at some point and go look at that. But that's exactly how I found my batteries. I rolled into a hobby town. I described how big of a battery section I had and how much voltage I needed. And the guy goes, "You need one of these," and pulled it off the shelf. And it fits like a glove. It's a little bit too long, so I've got to print some additional parts. But it is working. It works pretty well. And the first comment on the chat session is a link to an unlisted, unedited, about almost 14 minutes worth of video of me running my robot the first time yesterday afternoon and running around the yard. And I asked a little bit too much of it at one point, and there's some mechanical stuff I need to address at some point, depending on what I want to do on the thing. But it ran pretty good. It crabs pretty good. That crab is not as cool as your Mecanum floating sideways stuff, but it's pretty cool. And the spot turning seems to work fairly well. Kind of lose connection with my controller at the point, but camera works and all that other kind of stuff goes on. But I really got in here to address the there is a track you can go play. I don't know that that Wild Bill's over in Irving is equipped enough to build batteries like Mr. Anderson used to do, although I didn't ask any of those kind of questions. But it's an outdoor track, and it might be fun to go run down there and crawl over some rocks and things where it goes too long. Yeah, I was real happy that the thing worked, and I went up and down a couple of pretty good, what I thought were pretty good grades. Went over a rock or two, went in a ditch or two. Well, my driveway's kind of a ditch, so not a big ditch, but still a ditch.
So do you have a video of it?
Yeah, it's in the link of the very first in the comment and text in the chat.
Okay. In that case,
What did you end up using for tires?
I used TPU and printed slip covers. I printed the wheels just out of the model, and then somebody else had provided another model that was meant to be a slip cover. I had to print one to begin with to make sure that I have see if I can make sure I got light on me, that I had the sizing right, because I got to print 6 of them. And this is what one of the slip covers looks like. I guess I don't know if you can see it because I'm showing you. You have to look at my little page thing, and I'm just.
I don't know how far the web signals the wireless.
It's going to go, and then it's rubber, and so it does a pretty good job. And they slip. I made it small enough where when I slip these slip covers right over the top of it, the friction between all the layer lines on each one of these things holds it really solid, really firmly. I mean, I'm not going to be burning rubber or anything because this robot is going to be. I doubt that I'll even be able to get to I will not probably get the second cone, maybe in the time limit, just because this thing is not going to be very speedy, as Mr. Anderson pointed out last time, where rocker bogies are just going to be slow. And there you go.
So in case y'all hadn't seen it, I'm going to play a little bit of it.
Yeah, play a little bit of it. If you scan around a little bit there, I think I'm about to go down a fairly decent sized hill, at least for this robot anyway. I think it's a decent sized hill, and then turn right around and crawl right back up it.
Cool, Harold. That's really cool.
And you know, again, all the coding and everything is from Max and Miro, so
There it goes.
so it's a pretty decent down. I thought for
Pretty good grade there.
robots going on. And I'm filming this and driving at the same time, so my angles aren't that great.
We just went down.
Harold, you get the He Can Turn His On award for the week.
and it's kind of hard to tell showing in this video because
That stopping there is loss of control, not.
the robot itself didn't stop, and I got some pretty good wheel spin going on there too. But
Whoa.
there was enough of other wheels taking care of things to get me up the hill, and that's pretty much full speed right there, by the way. Yeah, if you go back just a little bit, this is going to be really hard because this is a kind of a step over, step through kind of thing that, you know, we go to the mailbox all the time. So we got a little rock there. And so I figured I would try it again. And basically the rocker bogie turned over on itself. So it's a bit of a mechanical thing. And then because of that same mechanical thing, if I'd had a better thing than just a couple of little nubs of plastic, keep the rear rocker bogie from spinning, it would not have turned over, and I think it would have stayed up straight and got out and corrected itself. Because right here, this is when it fell down. Wait till it scrolls down a little bit, you'll see what happened. See, if I could have stopped it from twisting that far, I think I would have had enough wheels on the ground that it would have backed itself off of that and been okay.
Well, and Harold, the one thing that Max and Miro pointed out, which is important to note, is that on this style of robot, the maximum size of an obstacle you can tackle is directly related to the wheel diameter.
Absolutely. So I know I was pressing my luck with this, and if I had a little bit better run at it, maybe, or the grass wasn't wet from all the rain, maybe. You know, there's a lot of that kind of stuff. You know, I was talking to my neighbors.
You can get a dog doing that on a video. My God, that just ups your rating.
You know, I know. I was talking to my neighbors, and I wasn't watching where I was actually filming, so that's how that came about.
Okay.
Yeah, pretty cool. Thank you very much, Sean. Thank you very much for showing.
Cool.
And so now I need to teach it. Thank you. Now I need to teach it how to. It can see because the camera's working just fine. It doesn't do anything with the image. I need to I was going to put a tiny LiDAR right next to the camera so that wherever the camera is looking, I can possibly get distance there, whatever the center of the camera frame is. The idea is, I could be completely wrong about that, but that's my idea I'm rolling with right now. And I need to give it a GPS unit and an IMU, and I'm going to put that on the top of that stalk off the back side of that. That's what I'm kind of designing up now. Now I'm going to put that in there and see if I can then teach it its orientation and teach it where it is in the world, and then figure out how to code it up so it goes from one waypoint to the next. Don't know which all those. I'm sure they're all going to be difficult, and I'm not sure which one's going to be the most difficult. So. But I got plenty of juice. There's a Raspberry Pi 8 gigs in there, and it's powered by a 3-cell, so it's 11.1 volt, 5,000 milliamp battery. And I think I dropped in that 14 minutes of running. I think I dropped 0.2 of a volt. on the whole thing. So, in fact, I forgot and left it. I shut down the Pi, but forgot to turn off the power on it when I went to bed last night. And I ran all the way through my Twitch stream as well. And I every now and then show it off on the Twitch stream and stuff as it running around. And I still got, well, let me see right fast. I've got 11 volts on my 11.1 volt thing. It'll charge up to about 12.5 on it. And you know, and that was when I turned it off this morning. There were some fans and things running on the inside. So I've got plenty of juice to go as long as I need to go, but I don't know if I'm going to have, I don't know if I can make the 100 yards in 15 minutes, let alone 2 or 3 of those 100 yards in 15 minutes. We'll see how far I get.
Well,
Yep, that's about what I had. Oh, hold on.
I'm doing the robot on this week, so. So I did turn my Romy on, and I'm gonna turn it on in a minute. What I said last time, what I was planning to do is do a semi-autonomous mode where I drive it around, but it'll avoid obstacles if it has to. And if there's no obstacle, it'll just let me do my thing. Before I show that, I also wanted to just show something about how I went about kind of editing and debugging the code. I've mentioned before I'm using Visual Studio Code most of the time. And what, let me start the sharing. Now, what I have been doing until recently is I have been using Visual Studio Code usually on my Windows PC, and editing files that are actually on the Romy, meaning on the Pi that's bolted to the Romy. You know, I have the folder from the Pi mounted to my Windows PC. You know, I haven't been using VNC much because there's just just enough lag in the user experience that it's just not really a great user experience. So for me, running something like Visual Studio Code natively on a Windows PC or a Linux, either way, is always the best user experience. So again, it worked fine editing the files that are actually residing on the Romy, but what was missing from that workflow was, well, number one, the syntax highlighting in Python didn't always work right because, you run your Visual Studio Code on your PC, it's going to look at, well, what Python modules do you have installed on your PC, right? And then it's going to complain about not finding stuff. Well, I have it installed on the Raspberry Pi, right? But my PC doesn't know that that's where I'm going to run that code. So, and I couldn't debug, right? Because this was Visual Studio Code running on the PC. Now, I found this Visual Studio Code extension, and I think it's fairly recent. Maybe it's been around and I just didn't know about it. But it's the keyword for those of you who are interested in Visual Studio and code and the things it can do. The keyword is remote. So if you just type in remote in the list in the extensions search box up here, it'll get you some bundles there. Remote and SSH are kind of the keywords there. The bottom line is what you get then is you get a mode of using Visual Studio Code where it uses SSH to connect to your remote computer. In this case, Raspberry Pi. So again, Murray, that is something you might be interested in as well. And then through SSH, it accesses the file system on the Raspberry Pi. But it's going much beyond that, right? It installs some back-end server software on the Raspberry Pi all transparently, and then Visual Studio Code running on your Windows PC talks to that other half of Visual Studio Code that's now running on your Raspberry Pi that knows all about certain extensions and whatnot, right? And you get now a screen like this, it looks just like I'm running Visual Studio Code on my PC, which I am. But again, these files happen to be coming right now from my Raspberry Pi, which again, that's not something new. I've had that before. But what's different here now and new is the fact if I hit this start button up here, it's going to actually run that code on the Raspberry Pi, not trying to run it on my Windows PC. I mean, that would be useless, right? But even more importantly, if I go into the debug, menu here, and you have to kind of sometimes tell Visual Studio Code what you're actually trying to do here. So I'm trying to debug Python code here. It's actually doing that. You can see down there, open terminal on my Raspberry Pi, and voila, right? I'm now in Python debug mode, using an editor running on a fast Windows PC with no lag and, real great user experience from an editor point of view, very snappy user experience. But everything is happening really behind the scenes on the Raspberry Pi. I'm now running this Python script here on the Pi, and I can debug it if I want to, which is not always practical, of course, on a moving robot, but sometimes it is. And so again, for those of you using Raspberry Pi, Python, I guess not even just with Python, it probably applies to C and C++ as well, because they have remote feature outside of Python. But especially with Python, where it's sometimes the editors you use don't give you debugging capabilities, right? Well, this will give you debugging capabilities remotely, for code that you have running on your Raspberry Pi. And again, it's just a very snappy workflow. And, especially when you're experimenting with some new logic and some parameters, I've said in the past, without a wireless connection, I mean, can't even do this anymore nowadays. And I don't have an explicit way here for tweaking parameters. I don't have that UI kind of set up right now. But you almost don't need to, right? Because making a change to the code to some parameter is so quick, right? I just stop the code, make the change, hit the start button, boom, off. I'm running again. And so it's a very fast turnaround kind of, experimentation cycle, which is maybe, again, one of those, if I ask myself, well, why am I struggling with Python, right? It's still a bit new to me. Well, I mean, you do get a little bit faster turnaround here than compared to doing C or C++, and you compile and you download, into your microcontroller, you hit the reset button, and then, it did seconds, maybe, a fraction of a minute for sure kind of elapse sometimes, and that just bogs you down, right? And so between Python and the Raspberry Pi and Visual Studio Code and what it can do, it's a pretty snappy workflow. So
Yeah, Chris, I can actually, I highly advocate for this solution. I've actually been using this myself as well. And the only thing I can add is that, I bought this little MacBook 12, little tiny MacBook, the one that's been discontinued. I bought a new one of these, not about maybe 6 months ago. And that's what I carry around with me. And I like to be able to do Python programming on it. And I'm using this, the VS Code extension, to when I'm near my Pi, when I'm within a Wi-Fi. One thing I've been playing with now is to run I'm just kind of doing this in the last week, is trying to figure out how I can emulate a Pi either in I'm not sure how you pronounce it, QEMU, or actually run a Raspberry Pi OS in VMware or, in a VM basically. So I can, when I'm on my Wi-Fi, I can do this with a real Pi, and when I'm actually on the train, I can actually do it to a locally running VM and just change the IP address of what I connect to through SSH. So you effectively have a fake Pi that you're running on when you don't have one, and when you do have one, you connect to a real Pi. But this is a great, the SSH remote on VS Code is really great.
So it's that same extension, you have been using that extension? Okay.
Yep, it's really
I
good.
don't know when it came out, maybe I just haven't seen it. But I stumbled upon it, and it's absolutely helpful, especially again for the debugging, because now you can debug, remotely. Which again, it's not a new concept. been doing that for years, Eclipse and GDB server running on some target. But in the context of Python, I guess I didn't have that before, and so I have that now. So now in terms of what it actually does, hopefully I don't run out of battery power on my thing. So very primitive logic. This is kind of version 0.1 of my obstacle avoidance. What it's doing is when the obstacle avoidance kicks only in when I'm commanding it to go forward. So any kind of linear velocity that's positive, I'm not really fully in control. Now, however, if I'm going backwards, the obstacle avoidance won't kick in, so I can manually get myself out of a jam. Or if I'm I'm using the other side here, or if I'm just spinning in place, it's also always me, the user, who is in control, so that I can always get myself unstuck by going in a circle, spinning on a dime and going backwards. But the moment I try to go forward or at an arc, right, the obstacle avoidance will kick in if necessary. That's kind of at a high level the logic, or one part of it. The other part of it is, right, as I get closer to a front obstacle, it'll slow me down, obviously, and then it tries to see, well, is there something on the left, is there something on the right, and accordingly, well, it starts turning. So pretty obvious stuff. It's not, again, it's lacking memory at this point. In other words, if it sees something on the right and starts turning left, and half a second later, the sensors pick up something on the left, and now it starts turning right. So it's gonna do one of these, because I don't have any memory built in. I don't have logic that says, well, we started turning right, so let's just turn for some time. So it's pretty stupid right now, the logic. But I'm using it more to sort of get a sense. Well, how good are the sensors in my cluttered sort of office here? Let me move the camera. I hope you don't get motion sick. And let me see if I can, let's see. All right. Let me see if I can move this thing and hold the camera at the same time. So you see that yellow toolbox over there. Let's see, am I running? Oh, yeah, I gotta hit the start button here on my. Gotta hit the start button here on my Python program. There you go. Now we're off and running. So I'm gonna go straight, and again, the idea is if I try to smash it into something, it shouldn't let me, right? I'm just gonna go straight ahead, try to go into the yellow toolbox, but it should, at some point start avoiding it. Hello? Okay, why is that one not working? Oh, there we go. All right, so it's wiggling around now. I don't know if you can see this, but it's doing a little bit wiggle left, wiggle right, because again, it doesn't really remember what it's doing. So I have to get it out of the jam here. So now it's going unobstructed, so it won't do anything interesting until again I tell it to drive into stuff, which again it will refuse to do. Again, even though I'm telling it to go straight ahead, obviously it won't do that. So again, very, very, very basic stuff at this point. I'm mostly happy with how my sensor assortment is performing. The obvious limitations are there, of course, with the ultrasonics and the IR. The one thing that disappointed me a little bit, and I haven't really used this guy before, the longer range sharp IR, it's getting confused by this plastic bin on this semi-clear plastic bin. It's getting confused by that. I don't know if it's causing some repeat reflection. What's happening is it's when I'm, let's say, 80 centimeters away from it, it might actually sort of it actually says I'm 40 centimeters away from it. Okay. And don't know why. Again, some weird reflection happening where it's giving me half the distance that I'm actually there. As I get closer, right, then it starts to, give me more real readings. So that I found that a little disappointing, but because then you get into the situation, right, which I have 3 front-facing sensors. Which one do you believe, the IR or the ultrasonic, right? So I was inclined to say, well, I'm gonna believe my IR sensor more than I believe my ultrasonic, but then I ran into that issue, and I'm scratching my head. Well, now, the IR is telling me I'm 40 centimeters away. The sonars are telling me I'm 80 centimeters away. Well, which one is it? Some obvious things we always run into, and I guess, what am I doing in my code? I think I have it now where I'm trusting. I think I'm actually have it, so I trust the ultrasonic more right now because of that. But when I look at, okay, what's my nearest obstacle in the front? Obviously, I'm taking all of the inputs and look at what's the nearest. But then for purposes of turning, I kind of trust the ultrasonics more than the IR. So in the gist, that's kind of the logic right now.
Hey, Chris, I have an idea about that milk carton polyurethane plastic, and that is you're going to get 2 kinds of light reflection off of it. One will be the actual light hitting the container and diffusing, and you'll also get the surface reflection. So my guess is that it's probably hitting, and the IR is hitting that and diffusing back, and it shows up as a large reflective object. And that's not the surface reflection, but as you get closer, you get the surface reflection, which would be therefore, I think, more accurate. So you might be getting 2 kinds of reflection off that material.
Probably. Yeah, again, it's kind of to be expected, right? I mean, all these sensors have the limitations. But again, all in all, I got a very cluttered space in here, and it's doing all right and picking things up. So maybe what I ought to do is add 1 more ultrasonic, because again, with all the clutter, it's going to do better in picking up the clutter, the small, sharp, objects are floating around on the floor. So that's probably what I'll end up doing. The other thing I was going to do, as I've been saying before, I really wanted, to start using my LiDAR again. So I'm going to probably put that one on top again at some point soon. And I was thinking, again, in the past I was using the LiDAR in conjunction with ROS, just because it provides, a lot of utilities and visualization things to go along with it. But the other thing I could just do with the LiDAR, if I don't want to sort of get into ROS and then get bogged down by that, is to just treat it as another obstacle detector. It just happens to have 360 of them, right? Because it gives you about a reading every degree. Okay, some of them are bad readings, so it has to drop a couple. So let's just say you get 250 readings for the full circle, right?
And you don't really
just treat them as individual obstacle distance sensors, and then you could group them into sort of, into sections and say, hey, what am I getting in this section? What am I getting in that section? What can I, simple logic like that doesn't require a lot of sophisticated processing of all the, thousands and thousands of data points that you're going to have coming in every second, So maybe something like that. I want to give that a try just to see, how far that can go and how useful that can be.
And the way you're using it, Chris, you don't really need the whole 360-degree scan. You probably only need 90 degrees out in front of you or something like that. So you have, maybe 50 or 60 individual sharp detectors or whatever. I would say, based on your experience with your milk tub there, my experience is slightly different. What I've seen is that I have those same sensors on a couple of my robots. And when I run it out in the hallway in the building where I work, they have these shiny metal kick plates on the bottom of the doors. And if it happens to look directly into one of those shiny kick plates, it says, so that it's getting a reflection directly back into the sensor, it says it's infinitely far away, rather than saying it's too close. But I agree, you can't really use those sensors for navigation. But by the same token, the ultrasonic sensors have weird failure modes as well. especially in a small, complex environment where you get multipath reflections that are stronger than the original reflection and so forth. So my general experience has been that I trust the ultrasonic sensors for readings far away, but not for readings up close. And for readings up close, I use a different sensor. I think last week I talked about using sort of a virtual bumper made out of infrared proximity detectors that only look out a small distance. But when you get up close to things, for example, with the ultrasonic, if you're up close to a wall and you're faced, let's say, 60 degrees along that wall, likely your reflections won't come back to you at all. Or they'll bounce off an end wall and come back to you and so forth. So I've seen, for example, a robot gets in under my desk where there's all those corner reflectors. Basically, the IR has to take over from the sonar, can't be reflected because it's just too weird. There's too many weird things happening. So as I say, my experience has been the opposite, that I trust the IR up close and I trust the sonar at a distance, but I don't trust the sonar up close.
Yeah.
Hey Chris, this is Raj. This is the first time I'm attending this meetup. Just wanted to share my experience with sharp sensors and the ultrasonics. I did a whole array of testing on sharp sensors and ultrasonic while I was working at a company here in Pittsburgh called Carnegie Robotics. We were working on an indoor autonomous scrubbing robot. And I tested a lot of these sensors. And I'm not sure if you had a chance to check the orientation of the sharp sensor. If it's vertical, I think it's good. If it's moving this way, you're supposed to have it vertical. That's correct, I think. Yep. The one in the front, the front one might be tricky. I don't know exactly how. On the side, it should be working pretty well in general. And with respect to the reflection, or the way it measures is not the intensity, it measures the angle of reflection. That's how the sharp sensors work. It's pretty cool technology, but then it has the weird issues, like when it sees a mirror or something very shiny, you might not get the reflection back to the same location, which is the other receiver on the sensor. At the same time, I did test the ultrasonics. There are some failure modes with that as well, like especially cloth. When you have like carpets or cloths that doesn't reflect sound very well, it's going to absorb and it's not going to be able to read it. Those are some of the issues, pros and cons. Again, there are issues with LiDARs too. I think the LiDARs are more powerful the incident ray. So the reflectance and also the sensors are more sensitive. So
the one thing with the LiDAR is, it's similar to the sharp IRs, right? They have a minimum detection range. And I forgot what it is on the RP LiDAR A2 or A1. I have to cheap on the A1. It's at least 8 inches. Again, I don't know the exact number, but you're looking at a fairly, a small robot, fairly large sort of minimum detection distance. So if you're up against the wall, you're gonna get zilch right from that wall.
Yeah. So I think you're doing a good job by adding different kinds of sensors on the robot. What you need kind of probably is a Kalman filter. If you haven't looked into it, something a little more advanced, complex.
I'm not looking for any headaches, and no, this is gonna be Kalman filter is gonna give me a headache now.
Chris, that response curve of those sharp detectors it's actually worse up close, because as the closer you get, once you're within a certain range, the further away it looks.
Yeah.
So you can't actually use that number to tell you whether or not it's near or far. One solution to that, which is not going to work on a little robot, is to mount the sensor far enough back from the front edge of the robot that you can't get into that range. But if I've actually been drawing diagrams about this for my
the other trick, similar to what you just said, if you can't mount it far enough back, I don't have it indicated exactly, but I have it pointing out at an angle, which already puts me a little further away from the wall, right? Depending on how I'm against the wall. If I had the physical space, I
this guy. He did the other way.
Is that turned on right now? We're hearing.
Definitely hearing like a cat purr.
Steve, where's my microphone?
You can't hear that? Oh yeah, it's still
Yeah.
there.
Definitely. I always wanted to ask Raj Shekhar if he could sort of summarize, based on his experience. There's a lot of us that are using those sharp sensors, and I'm using both the digital analog and analog ones, and I'm using the analog ones and the 5 of them on the front of my robot. And I'd really like to know how, if you could summarize how the vertical and horizontal orientations are best used.
Sure. I think you have to. Again, when I read about it, it's about when you have it horizontally placed and you're moving in the direction of the motion. All sorts of I don't know what effect that is. The reason why we hear the honk sound change when the vehicle is approaching us or the train is approaching us. Doppler effect, I guess. Something similar to that. That's going to kick in and it's going to cause issues with measurements. So you have to put it vertical, the sharp sensors. That way, when you're moving this way, right, the radius or the ray is going to hit and come back in this way. That's one of the reasons why the sharp sensors might give you wrong readings if it's horizontal. So better to put it vertical.
So I probably need, there's 3 of them right there. Those really do need to be turned upwards, don't they then?
Yep.
Okay, because the ones on the side are.
The one on the center is kind of tricky, but on the sides, definitely, yeah.
Yeah, the side one I've got vertical, but the 3 in the center are actually used, as you say, for that. So okay, I'll see if I can find room.
Talking about the sharps and things you got to watch out for, Murray, do you have an electrolytic capacitor bolted to each one of them?
I know what you're saying, but I haven't noted that problem actually.
Yeah, actually, I have to say for the 2 that I'm using here, which are on my side facing, they're slightly newer models than my other batch. I didn't solder a capacitor to those 2, and they seem to be doing all right. But I did it in the past, and I think in the older models, I have a batch of previous generation sharp IRs, more or less the same, but they behave a little differently. I think I definitely noticed the difference. So,
well,
you can see that if you hang a scope on the power lines, you can see those spikes, and they're pretty intense.
Well, the only thing I can say is that I kind of had known that this was a problem and that there was a recommendation for capacitors. And if I rebuild that front, what I call my integrated front sensor, which is 5 sharps and 3 bumpers, and or 3 just mechanical bumper switches, and that whole front assembly with all 5s is actually on its own power supply running into a little IO expander, which is its own little processor that's an I2C processor. So that whole thing is isolated from the Pi. So any spikes would only go into the it's actually a, what do they call, a 4051 or one of those little 8-bit processors, a little tiny chip.
yeah.
So I'm not having problems possibly because it is on its own power supply and not running on a Pi or a microcontroller.
Well, the issue I found with the older generation sensors, it's not so much that it's affecting other stuff, but right, the stability of its own readings, right, is also what you have to worry about.
Okay. Well, I frankly haven't done enough analysis to know that I'm not having that problem, so it could be there. Thank you, though.
If you look at the output of those on a scope, even though it's an analog output, it's not a continuous output. It's a series of spikes, and those can be problematic to sample.
Thanks, David, and thanks, Fred Shekhar.
Yeah, you guys can call me Raj. That would be really difficult for you to say Raj Shekhar. Yeah, I go by Raj.
Well, there, a few of us in the IT industry have worked around a few Indians before. But thanks for the tip. We'll call you Raj.
So do I get that on board now that because I turned my robot on?
Absolutely. Put put a gold star right there on your forehead.
So the next catch is, can you go for 8 minutes versus 4 minutes?
Who knows? A day may arrive when everybody will turn their robot on, and there will be great rejoicing.
Yeah, I'm looking forward to turning mine on again once I get things fixed.
I will say, Chris, and you too, Mary, that I have a lot of experience with those sharp detectors going back many years, and I've used them mounted in various different positions, and I have not found that is particularly controlling of their behavior. So my experience is a little different than Raj's. For those ones that you have set up to mount to monitor the wall, those ones mounted at 45 degrees, I've found that mounting them horizontally works fine.
Yeah. I guess I read the data sheet. I mean, what a concept, right? I read the data sheet. It says mounted this way, so I've always mounted it this way, with that one exception because I didn't have the space. So.
I can tell you that the ones I've tested, the ones that are mounted on my robot, despite the specs, and I'm going to talk in inches, are really reliable out to about 48 inches and not much more. And the way I have them mounted, I actually angle them down slightly so that they hit the floor at 42 inches, so that I always reliably, if there's nothing else to see, I always reliably get a signal back from the floor.
That's interesting.
And so I never get into that range where I don't really trust the signals that are returned. I basically limit that range.
And David, those are the ones that are listed as 50 to 150 millimeters. Yeah, so same ones I'm using then. Yeah. Those are great sensors, by the way. I noted that Pololu has discontinued one of their lines of IRs and are replacing them with a little board that has kind of like a directional LiDAR on it, and they're actually the same size. They're the same form factor or board size as the original ones, but they don't have any depth to them. They're flat. And I haven't yet tried those, and the optical specs on them are slightly different, so I'll have to kind of do a comparison. But I just bought 6 more of those sensors, so for the new round of robotics planning.
Actually, I've been wanting to try those time of flight. I think I may have bought one from Pololu a while ago, and still haven't tried it out. It's on my to-do list. It's a couple years old, that model. They come in various ranges and accuracy and sort of update rates. But I want to try them out. I mean, they seem to be potentially a good alternative to the Sharp IRs.
Do you think that they're similar to the VL051LOX or whatever that one is?
Yeah, one of those I have. I don't know which one, and forgot what range it is, what detection range it is, but I want to try it out, see how it performs.
Yeah, because I've mounted one of those, which I've forgotten. That was my lame attempt at remembering the model number, but it's a VL050LOX or something like that. And I mounted one of those on a little servo and was scanning back and forth, and that worked just fine. Actually worked really well. And I'm guessing that the ones on those time of flight from Pololu must be very similar sensors.
Yep.
Doug, we haven't heard from you yet. What's up?
Is everybody seeing the same thing I am, which is that Harold's screen doesn't have Harold on it, it has whoever is talking?
Yeah, that's how I'm recording.
That's because he's recording.
Yeah, that's fine.
Yeah, that's the only way I got to record at the moment.
So a while ago when you were talking and showing us your wheels and everything, I never saw you.
Yeah, John was showing the video for me. Yeah, which is cool.
Isn't it amazing? American business has been run this way for the last year.
Yes. And it seems semi works.
I just watched a video last night about this dude that pre-recorded himself in his office meetings.
Oh.
And played his pre-recording back for a week, and nobody realized that it was just a recording of him in the meeting.
Well, it beat me to it, except what I was going to do, I was going to get 4 different versions of myself chatting with each other and run those during the meeting.
You use the logic. Yeah, we could have the yeah, we could actually have a computer chip to pick the different models, and based on that, yeah, it probably could be done with the virtual.
David, I think of all people, we'd note it if you were recorded or not.
David, I do have one piece of information that you may not be aware of. There's a chain of stores called Battery Plus. Are you familiar with them? They do have the capability of building battery packs with metal nickel hydride.
Is that right?
Yeah. Now they won't do lithium, I guess, because they've had some bad experiences. But they will do metal nickel hydride, and you can buy really premiums. If you got the money, honey, they got the cells. I mean, you can go from, average cell all the way up to really primo cells. So if you need a new metal nickel hydride battery pack, you might check them out.
I just got one. I had to order one from online.
Yeah. I just show you it's a local opportunity, a local place that you.
Well, I didn't know that.
Yeah.
I didn't know they built battery packs, so that's good to know.
Yeah, I was replacing a Roomba battery pack or something like that, and found out that they could do that with better cells than the original, and so I went that way. So I think a Nito too. I did the same thing.
Well, the point about spot welding those cells and not trying to weld them or solder them yourself, that's exactly right. And people who are used to doing that can make quick work of it.
Yeah, I think if you got a spot cell welder, for them it's like beep, 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 and it's
that's what I mean. They do it all day long, so
yeah.
I found it worthwhile to pay somebody to do that. But Ian is bolder than I am.
Yeah, you can buy that metal.
I will say, the spot welder that I was using, when I made this battery pack that I just showed y'all, it did blow up and shoot blue flame out the side. But I was also told that was the cheapest one that the person could find on Amazon when they bought it. So that's not the one that I gave y'all the link to, by the way.
Yeah, there's at least one spot welder at the makerspace. Guys using kind of on a regular basis.
And usually these are really small, unless the guy's got a small one. At the makerspace, they probably have a professional one, for like welding quarter plate steel. Probably not what we'd want, but it's cool.
No, it's like specifically for the top of like 18650 batteries.
Oh, that's great. Yeah. I think I purchased the module to do that stuff, and I finally found got hold of my daughter had a blown up microwave, so I said, man, I'm gonna get a microwave transformer and I'll be able to do this. Well, she threw it in the trash before I got over there, but I did find somebody throwing out an old microwave, so I managed to actually get a microwave. So I'm it's one of those projects that after the robot is running on the floor, I'll get to, and so it's kind of in the queue. But anyway, there was something I wanted to tell you. Yeah. Nice.
David, you're on mute.
This is the last pack that Tanner made for me, and they're sub-C cells, if you know what those are. Mm-hmm. So that's a 10-cell pack, and those are 5,000 milliamp hour sub-C cells. It's got a Dean's connector on it. And I think I gave them something like $80 or something like that, which is not much more than the individual cells. It's pretty hefty. The nickel metal hydride they have some heft. Although there's good arguments to be made for why your robot should have some heft, especially if you're going to have it anyway. But I found a pack just like this. It had bare leads, but basically a 10-cell C-size nickel metal hydride. I found them online last year, and so I bought a couple more. These have been retired. The date on them says 7/23/14.
You know, if I don't know what the situation is that you're looking to, and I do not own stock in Hobbytown. Oh, let me forward that. Let me tell you that now. I do not own stock. Mr. Anderson might, with all his helicopters and stuff, but I do not own stock in Hobbytown, right? But if you have some requirements, just pick up your robot, roll down there, and start finding. If you go to a well-stocked one, they'll have umpteen billion different kinds of batteries and stuff with different voltages and that kind of stuff. Just roll down there and start fitting them together. Those folks behind the counter tend to be really knowledgeable about all those sorts of things, or at least I found them to be when I started asking questions. So, I mean, it may not work for Murray so well. It may not work for Murray so well. So, because I don't think Hobbytown's in New Zealand. So, but
no,
there's probably a hobby shop or something close to most everybody that I bet you can find some pretty, they're geeks of all nations too. So they get geeky about that stuff just like we get geeky about our stuff, and they're usually happy to help. At least I found them so. Anyways, it's just.
Oh, Harold. Yesterday I was actually in the one remaining company that's actually an Australian company called JCar. I'm not sure if they're international or not, but the guy that runs and actually owns the JCar stores, and I think there's probably about 4 or 5 of them or whatever, New Zealand. He personally has vowed to keep the stores open and selling electronic parts because it's the only company in all of New Zealand, because RS pulled out, that we can buy. We can go. I was in a store yesterday and I can actually buy resistors. And if that guy goes out of business, that's it. We don't have any more.
Yeah.
So yeah, it's a pretty small town here.
I'm not so much different. I just have to have Mauser 45 minutes away, and they don't do wheel call now because of COVID. But I still have to have them shipped. But still, I can't go down and buy a handful of resistors somewhere that I need, or a couple of switches that I need. That none of those stores really exist. Not that I know of, anyways.
It does remind me. I did have one question which I didn't bring up, which is I've been corresponding with John and another guy about the idea, and like I said, I've set up Fusion 360, a 3D modeling software. And so if this is a robot wheel deep, I'm going to try to get my motor inside the wheel, and this is some kind of an armature that fits like that, and this is my steering mechanism. I'm trying to model that in Fusion 360, and I'll get a step file or some kind of an output file, and I've contacted a local vendor who has not got back to me. So the advice I'm looking for is, if I was to design a armature and a wheel for a robot and get the output files, if I wanted to have that CNC made, like actually not 3D printed, but made out of aluminum or stainless, you guys have any idea what that might cost, and how feasible that is to have somebody build me 6 of those armatures and 6 wheels? Is that like $1,000 or is that $5,000? I have no idea. Anybody have any CNC experience?
It's probably going to depend on what stock you start out with. I mean, if you have something that is close to that shape, and he doesn't have to, hog it out of a block of aluminum, maybe I don't know what pieces would be there, but he may be able to get it out of like a square tube and cut one side of it off. It's really difficult to say, but yeah, if it has to come from a solid block, that's going to be expensive because it takes a while to get rid of all the material.
Well, then what I might do then is, rather than try to create a closed cylinder, is what I would do is just make the disc that would be the end of the wheels in mind with being able to somehow connect that to, let's say, an existing piece of a length of, let's say, stainless or aluminum tube that's available. Wow, David.
Yeah, Murray.
Yes, Doug.
One of the things that with CNC, it's a lot like a laser cutter. I mean, except you have a Z, you can do things in the Z. But essentially, if you're trying to cut plates, it's not a big deal. You should be able to get a reasonable price. But when you start to actually mill out something, that's when it gets really expensive. So one thought you might want to think about is Weldments. All right, where you take individual plates and weld them together to essentially make. You could do it with screws too, but what I'm saying is usually, or you can take. Another possibility is to take thin sheets of metal and bend them into your shape. All right, now I don't know if you have a brake or anything like that, so it might be pretty, you can do it with a couple of pieces of scrap steel, but it's a lot harder. But you'd be surprised how thin you can be and have a lot of strength.
How I would attack that.
I had taken a.
I would attack it. I would get into like 240 V channel and screw them together at the right angles, and you can get some pretty decent connectors that won't get in your way, so to speak, as well. If you do that as well.
Yeah, Harold's got a good point. That's if you can get it out of what do they call that stuff?
Yeah.
Extruded parts. If you can make it up with that's also real, not very, you can buy all sorts of extruded aluminum pretty cheap.
Well, there's two problems here. One of them is the wheel, which David's trying to talk about, and the other one is the sort of U-connector thing. And the problem with this is that this is cut out of one of those aluminum boxes, and it would work except that I have no control over the size of this is it. This is what I'd have to work with. But so there's the U. On what I'm calling a U armature, and I've actually sent a message to JPL to see if they give me the name of this thing. And then the wheel, and the wheel could be made out of metal with just the plate and then a tube, or I could get like the wheel that David will now describe.
Yeah, he probably got from Hobby Lobby or somewhere.
On most of these radio control cars, the way this thing, you can see how deep that wheel is. And it's actually made in two pieces. You see there's an aluminum nut here, and then this is screwed together from the inside. And the reason they do that is because they really don't want the pivot for the wheel to be out here. They want the pivot for the wheel to be right in the center of the wheel, which means it's got to be in here. So they have this large space to fit basically the steering yoke in there. But that's actually why I got these, because that's plenty enough space to actually fit a motor in there and actually bolt it directly to the wheel.
So and how big is that hole? About 3 inches, 4 inches?
Oh, let me get a ruler.
The only thing I'm wondering is that looks scale-wise quite a lot bigger than what I'm trying to build. I'm trying to keep
different sizes.
Okay, that's the deepest wheel I've ever seen. I've been looking and I couldn't find any.
That's a
the bigger they are, the deeper they are, though, by definition. So.
6-inch tire. It's a 3-inch wheel, and the wheel is 2.5 inches deep.
And what's the diameter? 6 inches?
Of the wheel, the tire itself is 6 inches.
Yeah, that's like almost twice as big as I'm looking. But do they have like a half size of that?
Yeah, this is. I mean, many radio control cars are built this way with a deep wheel like that. I got this one because I actually had some motors that would fit in there, and rather than building the bracket that you're describing, I was just going to bolt onto the back of the motor for the upright. So one end of the motor is bolted here, and the other end of it's bolted to this upright that then had a right.
Well, of course, for your purposes, that wasn't a problem. But if you're going to do steering, you do have to get that U-shaped armature to get above.
That's what I'm saying. I was going to bolt an upright here to the back of the motor.
And then tip that over? Yeah, okay.
Tip that over, and then this would steer.
Yeah, gotcha. Okay. Well, maybe in the mailing list or offline, and we can share the link to the company or whatever.
Well, I was looking to see if it said anything on the wheel, but it doesn't.
Okay. Because I was in a hobby shop. I was down in the South Island.
Night Japanese radio controlled toy car company, I think.
All right. I was in a hobby store about a month ago, and they had a huge selection, and I was looking through every single wheel, and I couldn't find that sort of sweet spot of depth and diameter. It's really hard. I really want a really deep wheel that's not too tall.
You know who also has a lot of wheels are the quarter scale radio control airplane people. And I use a lot of those wheels. I've got probably 20 of them right over here next to me. They build, different kinds of wheels that are actually have ball bearings and everything that are designed to go on those large radio control airplanes.
But you don't get that scale of really deep and not a big a diameter, though, do you?
You mean big enough to put a motor inside of?
Right.
No.
Yeah, man, that's the problem. Is that if you look at what a Mars rover wheel looks like, they're very deep and not very tall, and that's kind of the hard part.
So you'll be better off looking at the RC cars
Yeah.
versus airplanes.
So far, like that 6-inch wheel is beautiful, but that's like I said, almost twice the size of diameter wise. I think I'm probably going to end up having to manufacture either plastic or CNC an end cap, and then I can just put as long a stainless steel tube or aluminum tube or PVC tube on that as I want. That's probably what I'm going to have to do. The only downside of that is I don't have any easy way to make treads on that. Although, again, the Mars rovers, and there's lots of competitions for those kinds of rovers, often actually screw onto the outside of the tube teeth of some kind. So if I want to put several hundred little screws and tap them and everything, I could put several hundred screws onto the outside of each wheel, which would be both expensive and extremely time consuming.
Sullivan is the company, the RC company that makes a lot of those parts, and they have a group called Skylight. I don't know if you can see that, but there's a Skylight wheel. I've used a bunch of these. Here it is unpacked. I like them because they have this cross section that works real well with odometry because you have a very small area of contact. But they also sell things that look like this. These are wheels that are going to go on my large 2-wheel balancing robot, or things that look like this. This go on a quarter scale gas-powered radio control car. They have a neat thing. They do, all the radio control cars do this. If you see inside here, that's a press fit for a nut.
Yeah.
The problem of keeping the wheel from slipping on the shaft, which we spend a lot of time looking at, but it's really an elegant solution to it, which is basically just a nut that goes onto the end of the shaft and pulled in there when you mount.
Yeah, and you get a coupler on there with a flat spot on your round spindle, and away you go, right?
Yeah, and both Servo City and Go Build sell adapters for those wheels, by the way, that are made out of aluminum, and they fit onto their system.
Yeah, these are really nice wheels. These were also from a quarter scale. I can't remember which type of airplane, but these are airplane. You notice that they're set up with a pull a bearing, basically a nylon bearing. Mm-hmm. But they're
like that, right?
So you can put in your own drive fit.
Hey, David, could you put a link on that?
Well, I'd have to find one. Is that what you mean?
Well, not for the wheels, but for the company.
Okay.
Yeah. We can search for the wheels.
Yeah, when I made my order to Servo City, which I think I've mentioned before is all Imperial units, and now I've spent, I think, almost $200 and some on Imperial units, things I'm not going to use. Go Build is the metric. But like this is one of those wheels, David, that has that same hub. But again, it's not very deep. I almost thought about buying a pair of these and putting them together.
Interesting idea.
Yeah.
It's kind of heavy, though. Well, yeah, it is what it is. We'll see how much my CNC order costs. But thanks, Ray and others, for the advice on the design, because actually, if you design it right, that would keep the cost down. So.
When you design it, though, realize that you don't want underhooks. Effectively, what I'm saying is that the bit will go straight down. Yeah. Think laser, in other words. If you're going to do a CNC router type thing.
Mm-hmm. Well, the local company is like about a half an hour from my house, and if they don't charge like $500 a wheel or something like that, I could possibly. But if it's like, I don't know, there's 6 wheels. That's quite a lot of money if I'm not careful.
The best solution would be a resin printer.
And it might be a lot cheaper if you to design the whole thing flat and then have your machine shop cut it out flat and then just bend it at the 2 points that you need it to make your C.
Yeah. But I mean, the only thing is that fillet that goes on the 90-degree angles is really important, and you can't do a fillet that way. I mean, a bend is a bend. And one of the things I noted is that even in this, there's a little bit of flex, and that's got a pretty sizable fillet in the corner. And so I thought that in aluminum, unless I had some pretty heavy aluminum, it really needs that fillet, which would be part of the model, I guess, is put something in there that gives you that extra strength.
Yeah, that's what you're saying.
Although on the other hand, I've thought about this a fair bit. Actually, having a little bit of play means you've effectively got a suspension system. A little bit of bounce.
True. So in the meantime, Dad, how are you? Since I haven't seen you in a while. What have you been up to?
I'm doing well. I just finished school for the semester, so I'm glad to have that over. And I got a new 3D printer too, and I've been printing out a lot of stuff for a coffee robot I'm starting.
So what type of printer? Is it a resin printer or is it?
It's the standard printer. I don't remember the name for non-resin printers, but it's a Artillery Genius.
Yeah, I've heard good things about the artillery printers.
Yeah,
I've never owned one, but
really
I've heard
good
things. I've heard good things.
Mm-hmm.
What is it? What is a coffee robot?
So it's gonna make a mocha when I'm all done with it.
Oh, that's a very worthy project.
All right.
So it'll come to you and give you the coffee.
Well, it won't be mobile, but I'll just push a button and it will make a mocha for me.
This is sort of like David's idea for the mint julep robot.
I haven't heard about that.
It's not a real robot. It was just the idea that when you're finally done, you can just sit back and put your feet up and be entertained with your robot, not have to get up and go bail it out.
Yeah. Yeah.
But then the ultimate robot would then come over and give you a mint julep.
Mm-hmm.
So have you printed some? Have you begun this process?
I have. Well, I can't show it to you right now. It's actually pretty big and it's on the table in the other room. But so far I've got so it's going to be on a big track and it's going to go through each stage of the coffee making process. And I've gotten most of the track and the train part printed out so far.
Is this your own design?
Yeah, it is. Oh, wait, actually, I guess I could show you the, I could screen share. Oh, that didn't help at all. I could screen share the,
design.
Yeah.
There's tail file.
Yeah, 1 second.
Okay, while you're doing that, I'll bring up that there is a resin printer out there that is roughly, what was this dimension? I want to say 7 by 8 by like 9 for around $600 over at Micro Center.
Oh, okay.
So they actually do have bigger resin printers that are reasonably priced.
Oh,
now
interesting. Yeah.
So typically it was 2 by 3 by 5 for like around $300-$200. So
Yeah.
they're actually coming.
Well, they use those
for bigger.
They use those high-end cell phone. They use those high-resolution cell phone screens for doing the masking, right? So whatever the sizes those are.
Okay, describe what we're looking at.
So the two black things here are the steel beams that I've got, and they go a distance away. And then this thing right here is the part that moves the cup through each stage, and then it can raise and lower on this track. This is a screw drive here, and it will raise and lower the arm so that it will grab the cup first, and then it will move on to the next stage. And then this is a pulley I made, and that will be connected to a stepper motor that will push this train here back and forth.
Does the servo drive the gripper?
Yes, the servo drives the gripper here. And then there's a stepper motor here that raises and lowers the gripper. And yeah, so the next part then will be wiring it up. I've got almost all of this printed out. The only thing left is this piece right here, which will hold the stepper to push back and forth the train.
So the vertical stepper motor, is that screw shaft directly connected to the stepper motor?
Yes.
And the same thing with the horizontal one?
Oh, well, yeah, that will be connected to this pulley here.
Oh, I see.
Yeah.
Oh, are you happy with Tinkercad, by the way?
I am. I haven't really ever used anything else. I just like mainly the fact that it's free. But,
Yeah, because I just started using Fusion 360, which is free for 1 year, basically.
Yeah. Oh, really?
Yeah, if you gotta re-license it every year, but for a hobbyist, it's free for they've changed the licensing a little bit over the years, but for hobbyists, they've indicated it's going to be free forever. You just have to re-license it every year, and basically Fusion 360 is Tinkercad on steroids. There are a few differences, but if you're happy with Tinkercad, the Fusion 360 has slightly different concepts, but very similar concepts to move up if you want to move up.
Okay, because I did start using Fusion 360, but at the time it was only a month free, so I gave up on that.
Yeah, they don't make it easy. When you go register your license, you have to say you're a hobbyist and a few other things. You got a couple of hoops to jump through to get to that. I get this thing free and I get past the 30-day license. Now, when you do get past the 30-day license, they're going to turn a whole bunch of crap off that you're probably not even using. Like model generation, where you define a system and you give it some width and pressures and say, hey, make me the most efficient design out of this thing, and it'll generate it and stuff like that. Some of the CAM stuff they've taken away, and you're limited to 10 active designs. You can have as many designs as you want, but only 10 active ones at any given time. You'll just have to archive them all, but they're all there. You gotta, if you want to bring it up, it's kind of a pain. You gotta archive one and unarchive the other one to edit it again. So it's
well, Harold, the one benefit I found, and I'm not sure this is true with Tinkercad, is that like I've been playing with both the Servo City Imperial Unit stuff and now Go Builda, which is the metric stuff, is that all the step files for all of their products are available online and you can download it. In fact, it was either John or this guy Alexander that gave me a link to all of the files that they've downloaded and put into a bunch of archives. So I've downloaded all the zips for all of the Go Builda products as step files and brought up one of the servo blocks, and it gives you all the starter pieces, and then you would manufacture your pieces around that.
I'm doing that very thing. With the Exoma I have, they give you all the step files as well, and so I needed to do something with the mast, right? So I just grabbed the step file for the mast, imported it in, and then started building on top of that, and so I can cut my holes and do all that kind of stuff directly off of their model. So I don't have to worry about doing that measurement and getting it wrong, which I always do.
Well, it's good to see a coffee machine.
No, thank you.
Yeah. I have a question.
Yeah.
Is that artwork over your head a sketch of a young Jack?
Yeah. Yeah, it is. My
how old are you?
13, it looks like. Yeah, my mom would do those every now and then.
You tell her that it's a striking resemblance and that strangers recognize it across the
world. All right, yeah, I will.
And also, if you don't like Fusion, there's a Design Spark Mechanical. So there are a couple of different ones out.
Okay.
And it's set up with RS components or whatever. And if you use their libraries, you can download all the models of things like gears or switches or components. It's all available. And they also put out a PCB generation program, which you can do the same stuff. So AutoCAD 360 is great. I mean, it's a good skill to have. Design Spark is designed off of Space Claim, which is another major CAD program. And now, personally, Design Spark Mechanical is much more intuitive in what you can do with it. All right.
Okay.
But I think 360 is deeper. Okay, you can. There's other additional non-standard stuff you could do
Yeah,
if you were going to want to learn to do it. But almost any CAD can be done with either one of them.
Right.
But I'm saying,
I had actually downloaded KiCad with the idea, because it's free as well and looks really nice. But the reason I decided on Fusion 360 was that this local CNC shop only takes Fusion 360 files.
Yeah.
And it is obviously from Autodesk, it's a really professional package. And if you can run it for free, then great.
Yeah, and like I say, I just don't like the shape interface. That's just personal problem. I find the Design Spark interface much more intuitive. But 360 has a bigger I think it has a bigger learning curve actually.
Well, it does.
But if you can become proficient in it, I think it's a good skill to have.
But the key is they all tend to power the same. They just have little variations. Instead of left click, you do right click, and you might have like some menus that pop up from a menu.
Yeah, and like most CAD programs, the deeper you dig, the more flexible you find that the designers have probably anticipated what you want to do. But sometimes finding that particular option to how to do it is harder than you think it should be.
Well, it tends to get buried down in the menus.
Yeah.
That's what happens.
Yeah.
1.34 inches.
Yeah. Yeah, and just one last thought to Murray. If you do end up trying to mill something, 3D printing is, you can do things with 3D printing that you can't really do with a milling machine without extreme cost. Okay. So, you try to, when you mill something, you want to try to keep things as simple as possible.
Yeah. I mean, it's pretty easy to figure that the amount of material, like, if I want a 3-inch wheel, I don't want to mill that out of a 3-inch block. That's a lot of, and I've been trying to figure out how to get around that. And one way, like I said, was to be able to have a cap that I would attach to any kind of material, PVC, aluminum, stainless. And I can get stainless steel tube here, and it's not that expensive.
Yeah.
So,
I was trying to find it. I have somewhere around here. We got some spare parts from somebody, and they have exactly what you're talking about. It's a cap, and so what they do is the cap actually, it looks like a top hat, and so the top hat part fits into the tube, and then they have, like, I think 4 screws that hold that cap into the tube. Now, in your case, you probably would want to mill out you would want to remove the center of the cap so that your motor, you wouldn't be losing motor shaft length. You'd want to get close into, plus it's easier to attach the motor to the cap.
Yeah, I think
the shaft to the cap.
Yeah. I think the thing that I found was that that anything that I can have somebody else do that I can afford to have them do, like, for example, if I buy stainless steel tube, I can buy a length, enough for 6 wheels. But if I can pay them a cutting charge to cut those things to length, then the cuts are going to be perfect. Whereas if I do it with a hacksaw or whatever I've got, forget it. It's not going to look nice. Yeah. So that is to try to figure out where I can find local vendors who can do some of these things without charging me an arm and a leg. And it's just really hard to find that here.
Yeah. Well, machining, the problem with machining is the time. It's just, you're gonna, if somebody else is doing it, you're paying for their time, and it's going to be, so, something like, I can hack it off with a hacksaw and it's reasonably good. It's square enough, and I can make it square enough, or I can lap it down to where it's square. You don't want to waste your money on them doing that sort of stuff, I don't think. You want them to do the things that you absolutely can't do.
Well, one of the things I've still got is my possible card in the hat or whatever
rabbit in the hat or whatever is that I've been digging around in all the local plumbing and hardware stores for plumbing hardware because there's lots of joiners and caps and all sorts of stuff in 80, 90, and 100 millimeter sizes, all PVC, and it's not that heavy. And of course, you can just replace it if it gets damaged. So I'm kind of thinking if there's some way I can use plumbing hardware, that's probably what I'm going to go with. And then the only thing I'd actually have to have manufactured would be that U armature then, which is the one thing I can't seem to build out of Google Build or whatever.
If you can find the original thumper, the guy that, and I think it was in England, that built the original thumper, you know,
chassis.
Yeah, instead of the kit that you buy now, a lot of that was with plumbing parts.
Okay.
But it's a little hard to find that original article. But it's really, you know, because I mean, he made that base.
Yeah,
and he uses sort of a weird spring steel rocker and a few other things that, but it's all would be very doable by a you know, somebody at home with, you know, reasonable hand tools.
I've got pretty reasonable hand tools. Just the materials available here are a bit limited.
So yeah, I think the plumbing, with the original thumper, that combine those two together.
Yeah,
I think it's the strategy I would go with.
And actually, I want to say there's a guy, if you go out on Thingiverse, there's a guy on Thingiverse that from somebody in Australia who made a six wheel buggy, and looks like David's, okay, except he doesn't have the real fancy suspension. He achieves that suspension by having 3 rods that go through the whole, or otherwise the base of the robot is 3 rods, and he manages some sort of active suspension on, I don't know. I don't know if it's individual wheel. It might be individual pairings that can move. And so Thingiverse, if you look up robots, and then you might try robot rover. You might have to search for a while, but you could find some interesting ideas out there.
Murray, do you have a vise and a hammer?
Yes, I do.
Well,
I have a big, heavy Chinese vise.
All right. Well, you know, you can buy little pieces of steel. You drill your holes in them, and then you put them in the vise and hammer it over at 9 degrees and make your bracket. That'll just be as stiff as you would possibly want.
Well, the only downside, and that was sort of what you were talking about maybe 10 minutes ago, is that you get a little bit of springiness in that, and there's no fillet.
What I'm saying, if you get the right kind of steel, there won't be any springiness unless you're hanging, 150 pounds on it.
Another thing, now the case to your box, that's cast, so you get, you really can't screw with it too much. But if you were doing that with a rod of aluminum or steel, what you could do is at the corners, hold up your piece. Okay, you see where the those places, you can slit those a little bit and bend that piece either down or up. Yeah, up. Now you've got an I-beam type shape, which will be a lot stiffer. Okay, and if you can also buy this stuff. Do you have like a propane torch?
No.
Okay.
How about an arc welder?
No, unfortunately.
Okay,
I mean,
well,
go ahead, Doug.
I was saying with the propane torch, if you're working with aluminum, you have to have a really good system if you want to weld. But there is sort of I don't want to call it pot metal, but it's a low temperature brazing rod that's very inexpensive and very available at the places like Amazon. So you can do a little cut like that, fold it up, bend it up. So now it's, like I say, it's a U on the top and the bottom. All right, and so now you got some real strength. And you can, if you're worried about the little corner, you can just touch this stuff, and all you have to have for that is a little propane torch, which you can buy for like $5 or $10.
Yeah, because my brother used to race motorcycles, and he built his own motorbike, so he had learned how to TIG weld. And to do aluminum, you really have to have the right tools.
Yeah, but this stuff is the cheap way and the hobby way to do it.
Yeah,
I'm kind of with Mary on this. I think you ought to be able to go down to the hardware store and wander up and down the aisles and find, I don't know what the hell this is, but it's exactly what I need.
Yeah, no, exactly. Yeah, I used to do that all the time, especially in
cast aluminum or something, maybe.
Well, we talked about this last week, is that you used to be able to go to like salvage shops and just find pieces of something, but there's nothing like that.
Another thought would be two L-shaped pieces, and you overlap them at the bracket side. Okay, so that way you could even add some adjustment if you wanted to.
Well, the other side of this, which I haven't really mentioned, is that part of this is kind of to open source what I would be doing. So I've got offers of help from John and this Alexander guy about doing this. And if I can come up with the step files, I would release them to the public. And if anybody wanted to build a robot of a similar scale, they could download these two parts and either 3D print them in plastic or take them to a CNC shop, or if they've got a CNC machine, they could do it themselves. Because one of the things I've found is that nobody anywhere is making Mars rover style robot wheels and these armatures anywhere. And if I could come up with a design, even if I couldn't afford to do it, I could still release the files and other people could go ahead and try it out.
Marie, have you looked through I assume you have, but all the various hardware and brackets and so forth that they have at Servo City?
No, I haven't.
They've got all kinds of things for making robot arms. And,
it's Servo City. Yes, I have actually. And,
I would be surprised if they don't have something like that, or if it couldn't be bolted together out of something they sell.
Well, that's kind of what I did here, and generally speaking, you could, in theory, from Servo City, but like I've got these big, heavy L bracket things, which are kind of expensive, and they're not long enough in one dimension. They're just that size they are, and both GoBuilda and Servo City sell a wide variety of these things, and the idea of spending like $200 like I did as an experiment was to see if I could come up with something. And this is fine, but you end up building a robot because of the parts that you can get a lot bigger than I want. I'm trying to make this thing smaller, kind of on the ExoMi scale, maybe slightly bigger. And any robot built out of the Servo City stuff is going to be like almost twice the size of that. So
we actually have
great stuff. I mean, they're both GoBuilda and Servo City. It's beautiful hardware. I mean, these are really that's a gorgeous piece of engineering right there. A little double bearing, and it's really fun. It's like the most expensive Lego you can think of, but it's these two pieces, the wheel and that U armature, which I can't do. Everything else is probably going to be GoBuilda at this point.
Doug, at one time, many years ago, but you were in the group, I gave a great big box full of RC car suspension parts. Do you know where those are?
I still have some.
You have them, all right.
I don't have them all, okay, but I do have some. The problem is most of them are like 1/16 scale and one.
Yeah, that's what I decided.
Yeah, and so they're a little.
Yeah,
but
I went to the 8th scale for the actual robot.
Yeah. Now I will say this on Murray. We had some club members who built the Mars rover. They were sponsored by Vex Robotics. Jason and Paul, and I think it had 27 motors. I mean, it was just this incredible thing. But you're right, it was a monster. It was big. I mean, it was not the size of what Harold showed. It was probably 2 or 3 times that size.
Yeah, because what I'm ideally trying to do is build one on the same scale as this. So I'm going to use the 22 millimeter motors and wheels that are probably 70 mil diameter, trying to keep the whole thing on a scale where I can use the size of batteries and the size of motors that I have been using, which means it's about the size of the ExoMi. But it will be exceedingly complicated. It's going to be 3 computer systems, and all that. But in terms of weight and batteries and motors, is I'm trying to keep it as small as possible, because as soon as you go to the next stage, then your batteries and everything is just that whole size bigger.
Mm.
So I found this. I
scroll
don't
down?
know if you all might like it or not. I'm like, right, putting the more inside the real bit. So you might glance at that. I'm like, okay, is that interesting thought?
You know, put the link in that, please, and I'll take a look. This does totally fulfill my fear, or confirm my theory, which is, I've been like Harold and other people, is that actually 3D printing is a religious cult. I'm pretty sure of it. Every time you have a
Yeah, it
conversation,
is.
somebody comes
Come
in
over
and
to the
says,
dark side, Murray. Murray,
What's
come
that?
over to the dark side. It's all right. Come over to the print side. We hear ejective veins with a little PLA. You'll be just fine. It only hurts for a minute.
PLA, it could be resonant. Resonant's a new thing, you know.
Oh yeah, resin wheel.
Eventually,
Oh,
slowly
no,
get to metal.
We won't have to. Yeah, we won't have to inject the resin. It just absorbs through your skin. It's awesome.
But I mean, you know, if you get into a 3D printer that's capable of ABS and nylon, you know, and those things, they don't even, well, nylon, for example, ABS has some problems, but nylon, when you're finished printing, the layers are actually fused together as one part, and it is practical. I mean, it's the only thing I know that you get strength in all directions. You know what I'm saying? Like if you do it with PLA, you've got a strong direction and a weak direction. For example, if you were to make a big cylinder, okay, and then on that cylinder you were going to put a small cylinder that was going to be your shaft, where you're going to put it over your shaft. That's going to just layer break right at where the little shaft and the big shaft, or the big circle and a little circle are. It's just going to break there, because unless you print it up and down, okay, like this, which then it gets really weird.
That's where a resin printer is nicer, because it actually does.
So layer you don't have as much, but I don't know the strength of those materials.
Oh, they're pretty strong. Believe me, I was amazed when I can't open them.
But John or Doug, if I want to print in in nylon, I'm using a resin printer?
No, it'd be using a regular printer. But you have to have one that has, you have to have an enclosure. You have to have heated bed that can go up to 110, 125, as opposed to 60, which is one of the problems with, like what are the creatives, or not creatives?
Yeah, the Crealities. Most of those printers
they really can't do ABS.
Yeah, most of those printers, Crealities, are not sold with enclosures. People will put enclosures around them. They will get hot enough. They will get to 100 degrees C on the bed after a little while, but you have to make your own enclosure and a whole bunch of things like that. And like Doug was saying on this, nylon's great. I've never printed with it.
I'm not going to join the call. I'm not going to join the call.
I've never printed with it, only because you need so much more hotter temperatures with your hot end of your bed and that kind of stuff. The entry-level printers aren't going to do this for you. They're just not.
Harold is such an acolyte. I swear he's already in the call.
Murray, I can say, just as an aside, that using raw nylon, machining raw nylon, is actually a pretty wonderful robot material. You could easily make those jaws that you're making by machining out a U out of a little piece of nylon, and it wouldn't flex. It would be really strong. Nylon is because you can drill it and cap it, and it's.
And then you can put RGB LEDs in it and make all your wheels light up and go crazy. Just like hydraulics and underneath the car.
David, as you know, my sort of du jour plastic is 3 mil Delrin. I've been making everything out of that, and I'm a huge fan of Delrin.
That's good stuff.
And I do know nylon and Delrin and all the plastics fairly well in terms of materials. Obviously, nylon's not a Delrin, and I don't know. You can machine Delrin. I made an animation stand in university out of Delrin block. It's tricky, and I have a scar hand from accidentally letting one of those in.
It's a little gooey to machine, but it's a pretty neat robot building material.
You mean the nylon?
Yeah.
Yeah. Delrin is better, and I can get Delrin. In fact, I've been using blocks of Delrin. I think this must be 6 mil or maybe 8 mil. It's amazingly strong. And there's a guy up in Auckland who can give me Delrin up to, I think, 10 mil. So that might be another way to do it, is just build it.
Well, you know, considering you're a large robot or not wanting it to be a large robot, and there's good arguments for that, especially when it gets large enough that it's hard to carry around and work on. But I have a true story I will tell, absolute true story. In 1993, I was doing some work for the Jet Propulsion Laboratory, and I was out in California, Pasadena, and I went in to see these guys who were working on a Mars rover. And they told me that they were going to build this thing, that it was going to be about the size of a Volkswagen. It was going to carry all this amazing equipment. But before they could do that, they were going to build a little bitty model, you know, a little thing about this big, so they could test it here and test out all their science and their algorithms and everything. Well, evidently what happened is the years went by, and they came back and they said, well, we cannot afford to lift your Volkswagen-sized robot to Mars. However, the little model you built, we actually could take it. And so that's what they ended up doing.
That's the Sojourner.
Yes, the one that they launched recently was the big one that they were told in the 90s was too big and that they couldn't get it to Mars. So they actually wanted to build a bigger one, and we're not allowed to.
Well, it's interesting because I think I might have mentioned before that I was actually working at NASA headquarters I was a contractor, but Dave Lavery was the head of robotics at the time, and he still is. And I was the Macintosh support for their team. And Dave's a huge Mac enthusiast. He was like the most Mac enthusiast on that whole Code X where I worked. What's that?
Speaking of cults.
Yeah.
Yes.
But on Dave Lavery's desk was the Sojourner prototype, the one that they had sent. So, David, you and I have this weird connection then, because actually
both seen
that prototype was sitting on his desk, and I, at that time, was admiring the beautiful machining on those little aluminum wheels. And that's kind of what got me thinking again, like, oh, if I could possibly afford 6 of those wheels, wow.
So, Murray, what you're saying is, I want to figure out a way to do this gorgeous piece of machining, but on the cheap.
Yeah, exactly.
So, speaking of that, then, so you could probably, I'm thinking, cut your plastic nylon using those shapes, right?
John, you are such a cult member. This is exactly what I'm talking about. Every time I turn around, someone's throwing 3D printing at me. Like,
no. The reason why I'm showing this one, though, is basically those parts you can cut out using a nylon relatively thick material, right? Mm-hmm. At the angle, it's my thought.
Well, it's those purple things. Yeah.
Right. See, that's what I'm saying. This part here, you see, if this is the top, of your sheet, you would just cut out that shape. Correct? Mm-hmm. At least that's my thought.
No. I mean, if I was to get, I'm not sure how thick I can get the stuff from.
Well, that's the trick I would have. But if you can get reasonably thickness, then you could just basically get a throw saw and cut out that shape.
Yeah, or even if I got, let's say, if I can get 10 or 12 mil Delrin, if I got 2 of those pieces together, it'd probably be enough. And then I can cut any shape I want. It's a lot of labor, but...
but hey, it's a thought I have going with this. And that's why I brought this one up, because it's relatively flat pieces, if you look at it.
Yeah, because like this is, for example, I think this is... Oh, hold on, what do I do with my rulers? Put them all somewhere else. Anyway, this looks to be about maybe 8 mil Delrin. And this stuff is it's incredibly light, and there's no way this is ever going to snap. It's just about impossible to do then.
So, So, Dave, what were you showing?
I was going to say stainless is probably going to be much more expensive to machine than aluminum. Some of the stainlesses can be very hard. Might not even be able to use the same tools that they could use on aluminum. You could use a high steel.
Yeah, exactly.
On aluminum, but most likely not. Probably chew it up with the stainless. So You need a cutter.
Well, I was only thinking of the stainless for the tubes. Like if I was to do the end cap
Yeah.
and aluminum, have the tubes be stainless.
Right. Yeah. So
And that
minimal
would be
heating in that.
And that would be going to a stainless tube supplier and saying, rather than sell me 1 meter of that tube, could you sell me 1 meter but cut 6 pieces for me? You know?
They'll do that. They'll do that. Yeah.
Yeah.
What I was going to show you on it, I only could find little tiny pieces over on my workbench, but this is a piece of that just raw nylon that was cut out of a sheet. That's 3/8 inch, and I think I had like a 1 foot by 1 foot sheet or something like that. But it's real useful for the Delrin. This is probably something you already know, but super glue works exceedingly well on Delrin. And so what I have here is I don't know if you can see, this is 2 Delrin sheets super glued together in order to get whatever thickness I needed to machine. And that, that's permanent, and you can't even see it when you look through it. It doesn't leave a pattern or anything. It squishes.
Well, I've been sitting here talking metric, but this ruler goes both ways, and I'm just flipping this, and this is actually 3/8 inch Delrin. So, and it's just like really light, really strong.
Yeah, and as I say, super glue works real well on it. You can build things out of super glue.
Okay, cool. Well, maybe that's what I'll do then, because frankly, we'll see if I can get any kind of a quote or even a rough estimate from this local CNC company for the wheels. But, it's one of these things where, build it yourself versus CNC would be nice, but if it's going to cost like, $500 a wheel or something like that, I'm not NASA.
Also, you don't get the option of making mistakes. I don't have a 3D printer, but I'll tell you what I'm jealous about. And Doug and I have talked about this before. When you machine something, you start with a little block of aluminum and you make your first pass, and you start milling it to the shape you want and putting holes in it and so forth. The more operations you do, the more holy that object becomes, because the longer it'll take you to get back to that stage. And when you screw up,
precious.
Yeah, it becomes precious. When you screw up in the first half an hour, that's not a big deal. But when you screw up after 12 hours of working on the thing, that's a real head buster. On the other hand, with the 3D printer, when you say, oh, that should have been a little thicker, you don't actually yourself have to do anything. You just have to print another one.
Yeah.
And make that part a little thicker. And that part I'm jealous of.
Well, I will say this.
I will say I always make at least 2 and maybe 3 of everything I make. Because a year from now, I won't have all the jigs and the setup and everything when I need another one. So if I could buy that rather than make it, I always would.
Yeah, from 3D printing, the fail fast, fail off and works so great. I mean, and it helps you in a lot of things, like just getting things straight in your mind. The first couple of designs you make, once you print one out and you look at it and you say, well, what was I thinking? It's just way, it's the best $200 you can spend.
Yeah, but my guess though is that I'm not the kind of person who wants I'm not the kind of person who wants to deal with all the idiosyncrasies of direction and printing. I like the idea. Like, this is the first time I've been almost introduced to the cult was when you mentioned printing in nylon. That's kind of enticing.
Yeah.
And I guess the cost for those printers is a lot higher.
I will tell you, the $200 printers are pretty good. But what you're going to do is you're going to have to get in the cult, because the $200, they're good. But if you want them to be great and actually do really wonderful things, you're going to have to print mods. And the first thing 3D printer guys do is use a 3D printer to make their 3D printer better. And now you're inducted, and you can't get away from that. Other than if you want to spend some more money, like get you one of the original Prusa MK3s, I think that will print nylon if you get a case around it. I think it goes high enough for that. And you will not be inducted as much, because that'll just work right out of the box. In fact, you can even order it you can even order that thing put together. So literally from your time you get it in your house to your first print's about 10 minutes.
It was actually a pretty good one.
Like I say, Murray, think about, you were telling me, how much did you spend for shipping the other day? $200. You could add a 3D printer. I mean, it's the best tool that you can get.
See, man, I don't even have to push it, man. I don't even have to push it. This is awesome. I'm not pushing
Maybe you
it.
should bypass that and go directly to the resin print.
Oh, look at
I
God.
wouldn't go there.
They're nice. I have
They're
one.
nice, but they're small.
How much was your new printer?
Let's see. Okay, not that one, but you see those two over there?
I think you're muted.
My printer was $300, and it's been a really good printer. It also, I was able to put on a auto bed leveler for $50.
So 350 was your total outlay?
Yeah.
That's very reasonable.
Mm-hmm.
So that's about $500 New Zealand.
Yes.
Plus 1,000 to ship, right?
No. Believe it or not, Audi in Australia were selling at one point ANET A8, which is a decent beginner's printer on the whole thing from and Audi. You go to the grocery store and come home with a 3D printer. Maker's Muse, Angus, a guy that's from Australia, he's a big 3D printer guy down there, and they were selling it. It was a couple years ago now. I don't know if they still do that or not here and there.
Once a year.
Once a year.
Well, Harold, the only way you're going to get me involved in this is if I can print nylon.
Yeah, you'd have to upgrade that printer to be able to print nylon, because you're going to be looking at a hot end of somewhere upwards of 280, 290, almost 300 degrees Celsius to be able to drop nylon well.
You have to have all metal.
Yeah, it's got to be all metal. You can't be messing around with that. Yeah.
Because most of the cheap ones use a Teflon tube to do as a guide, and that'll melt with temperatures.
And the Teflon and those tubes and on the most of the cheap ones you can get tap out at a hot end of about 260. You may drive them to 265 or 270, but you're pushing it hard, and that you got to go in and get custom software. You got to go tweak the firmware to allow you to go that high.
Yeah, the first one I would buy would be that Ender 3 Pro right there.
Jack, maybe you already
got a good
discussed
reputation.
What software did you use for the driver? Did that come with the printer, or did you have to download that?
Me?
Yeah.
I used the Ultimaker Cura software.
Free.
Yeah,
But you can print from a step file, right?
It's free.
Yes, you can, but that's not the preferred.
STLs.
Yeah, they like a STL file, but everybody has STL.
Fusion 360 could output that, right?
Yes.
Yeah, no problem.
Yes.
So you're designing it there in 360, and then when you're done, you output that as, I don't know, what are they, Gerber files?
They're called G code. What? I'm sorry.
There's STL files, which just are shell. Okay, the inside's not really in it. But then you use what's called a slicer, and the slicer creates the G code, and then it's just a G code. It's just like CNC or anything else.
Oh, okay.
It just pulls it out. You instead of cutting material, you have something that's basically a liquid goo that's going to be put down like toothpaste over and over and over again.
I've taken describing it.
They can literally do things that you can't do with milling machine, because they can make different infills. They can, and like the one that Jack's using, which is more complicated than the one I'm using, actually has the ability to make different step heights at different layers, so that you can like customize where I need a little more detail here, but here I don't give a frick. You can let it go. You can adjust that. There's slicers have really gotten complicated now. I mean, not complicated, but sophisticated, I should say.
Was one of these ones we're looking at the one Jack bought?
I haven't seen it in there yet.
Yeah, he bought an artillery. So if you just do a search for artillery, Micro Center's not going to sell them, I don't think.
No.
I have to say that this is as close to joining the cult as I've got, and the idea would be I would only be interested in printing some kind of a stronger plastic like nylon.
Yeah. And I got a roll of the stuff that Harold was using. What is it called? Something
Tough PLA.
Tough PLA. I'm real curious because if that works, if that's closer to ABS without all of the hotbed problems.
That's what they say. I didn't have any
really
warping.
nice.
I didn't have. I mean, I've got an enclosure around mine, but I didn't have any warping at all.
Yeah.
No lifting, none of that stuff.
I have two printers. One set for PLA, which I use 95% of the time, and then one that's got an enclosure that I built out of using an IKEA.
Yeah,
those
lac tables.
$19 or something like, yeah.
Those lac tables, very popular upgrade for most people in their printer.
Yeah.
Well, I just online found at Dick Smith Co. NZ the Creality Ender 3 version 2 3D printer for $359
Right.
New Zealand. Would that print nylon?
Probably
You
not.
have to go spend.
Probably not, yeah.
Probably
Okay,
not.
so what do I need to look for to find a printer
You
that
need-
can print nylon?
You need
It
a
has to be
hot
in
end.
code.
You need a hot end that will go to 300 degrees C.
Yeah.
But
Well, it has a brass nozzle, but I guess what it sounds like is I also have to have one that has an enclosure around it, right?
Okay. So Murray, how the extruders work, generally speaking, is it's usually stainless steel because of the heat characteristics, and you have it's hollow, and you slide a 1.75 millimeter piece of plastic, depending on which one you're trying to melt, down through the middle of it, and there's a place in that tube where it has been thinned down considerably to where it's just very, very thin, and that acts as a heat. It's like a high resistance area, so the thermal transfer across that thin area is very slow. All right. Then below that, they have a heater block that melts the plastic, which fills up the little nozzle that you saw, and then squirts it out the end of the nozzle.
Yep.
All right. Now,
so here's an example of one that will do it.
yeah.
Okay, if you look over here, guys.
You don't need that.
I hate to tell you, but that printer in New Zealand sells for $1,680.
Yeah.
The materials there is PLA, ABS, HIPS. So that's why. And then there's the software that you would download and the file types.
Yeah.
Well, it sounds like this is, if I was to do this, it's basically adopting a whole nother hobby, isn't it?
Yes.
Yeah, probably at first, but it's one of those things you get if you got jobs, i.e., you're trying to accomplish something, so you're going to want to learn, and you're making parts for your robot. You will learn real quick, and I'll be quite honest. They have made enough. The Chinese printers, the inexpensive Chinese printers now, print good out of the box. They may not print perfect, but for a robot part, they print great. Okay? And in the old days, like when John and I first got involved,
we built our own.
We built our own printer, and it was at that time everything had to be tweaked. But now, when I bought these two printers, they're Wayland. Let me see, Mount MALYAN.
Malian, yeah.
One.
Yeah, M150s. Yeah, I don't know if you can buy that model anymore, but I literally bought one for $157 because it was on sale, and I think I paid about $200 for the other one. And yeah, Hobby King, and I ended up putting a lot of like Harold said, I looked out there and found all the mods that people had done, and I put them all on there, made it a sturdier printer, and I haven't had any problem with them, none. I had a broken water which I misdiagnosed, and because of that broken wire, I ended up having to replace the controller board, but it was because of my own stupidity. Otherwise, the controller board I screwed up was perfectly fine. That wasn't the problem. But other than that, I literally haven't had any problem.
Now, the one that John is showing right now, the Creality LD006, that's not going to do nylon, though, will it?
It might. Any materials out there, you have to go look.
I don't know. That resin is different. Resin And the problem with this one is probably bed size.
No, it's pretty
Yeah,
big.
well,
That's why I said this is big for his price. It's
Yeah,
amazingly big.
Yeah, but if it's different nylon, it's not going to suit. So
yeah. Well, I don't. You gotta be careful. Resins might be.
You don't need to look at the
They
resin
might, yeah, you'd have to look at their mechanicals first.
because the reason why I have a resin printer mainly is because I can do lost cast in the process. In other words, I can do lost wax basically. In other words, I print out the material and then I burn out the material to cast.
Yeah, and another
And you
thing
get
is,
detailed resolution with this. I mean, jewelry level, quality.
for detail, you can't beat a resin printer.
Right, and that's the reason why.
Yeah, well, I will say this.
There's another rabbit hole. You could cast your own aluminum parts.
Well, that was my original thought.
oh my,
No, don't go there.
That's a whole different goal.
Yeah, yeah. But I will say that there are resins that might give nylon a run for its money, but I don't know what they are. And I know that my daughter uses a resin printer in her dentistry practice.
Right, and that's like wax.
Well, I'm still, I mean, I hate to say, but maybe I'm just old enough to be in the old school with you guys because I'm thinking that David's idea of just manufacturing the thing out of maybe Delrin or nylon sheet and just building the thing
That's
is
great.
probably more my style.
Yeah, but I would say that why I would say the 3D printer is so cool is because of prototyping.
Yeah,
Okay, I mean, and you will find that there's a lot of parts that 3D printed parts are perfectly fine. I mean, there's no problem with them. I mean, you print it, you say, hey, this works, and that you never touch it again. It just works, and it's put in there.
Well, there's two pieces that I need. I need six.
And how many pink parts can you have? Think of it. You can have pink and purple, and Harold's got a whole bunch of weird colors on.
Oh
his.
yeah, and there's way more than that.
Days in the 60s, yeah.
Yeah, but I'm just saying. But it's that prototyping. Because you don't have much time for your hobbies, or at least, and I've got a lot more than probably most because I'm retired. But just designing a part and getting it out and quick.
Well, and Doug, the one thing I have to keep reiterating is that I need 6 of these things. So even if 2 of them takes a long time, I've got to do it 6 times, and that's just a lot of time.
Okay, like
Where you know that, I'm sure you know this, but you can buy aluminum extrusions.
Yes.
And they're quite strong. And this is one I use when I want to square up things on my blade. It's just got a bunch of holes in it, but it won't bend at all. I mean,
No. That's like how strength.
You can also buy these in U channels, which it sounds like what you need, although I'm not quite sure why. Seems like this would do. That is, if you've got your motor mounted here with a wheel on the end of it, and you have your pivot here.
Well, I've tried to describe this to somebody locally. The problem is that on these motors, the mount is not on the back; it's on the front, and so
that can be fixed with some standoffs.
Well, yeah, but basically, I've got to have a piece that goes all the way inside and mounts to the front of the. I'll hold this up. Here we go.
Well, that's what I'm saying. You put standoffs along the length of the motor and attach it from the back. There's always a way to do that.
Yeah. I agree.
In which case, one of these would do.
Just with long standoffs.
Yeah, you have some standoffs.
It's not very elegant. You're about elegant.
Is Harold still with us?
Yeah, I'm still here.
Hey, Harold, show your robot again. Let's see why they did it. Why do they have that?
I don't have a good way to show you that without messing up the recording.
Okay, never mind.
You want me to run the video again?
Yeah, John, you show us.
He can do that, or let me give you. I can give you a thing. I can give you a link in the.
Oh, well, yeah, that I was just going to run the whole thing.
Well, I don't know if it's
Pause
going to
it
show what
somewhere.
you. I don't know if it's going to show what you need to show. Hold on, something. One second.
Okay. If you want to do that. In the meantime, let me.
I think they're just using it to support the servo, though, isn't it?
Yeah. Let's see if I can. Let me get
So I
to
think
the.
David's idea could work.
Well, I mean, I hate to say, but
might find some, might be some protection.
those extrusions are actually kind of hard to find in New Zealand, but I think I could possibly find some of that kind of stuff. It's I know in the U.S. it's just easy. You go anywhere and that stuff's available, but here it's quite a challenge just to find it.
I went to Garland.
Open builds.
I went to Garland Steel.
Gerald, do you send those
Industrial supply place,
link?
and you ask them, the keyword you want to use is you ask them for drops. Drops are pieces that they cut off. So they had a 20-foot section of pipe and they cut off 3 feet for somebody. And so you say, can I look at your drops? And there'll be all kinds of things and they'll sell it to you by the pound.
Okay.
Well, John, if you'll click on the link, if you'll click on the link, you'll see this is how they want you to print those things, but you get an idea of what theirs looks like. Basically, what they've done is just like we've all been talking about, and you're actually using part of the servo to make it part of stiffness, because if you'll see the two holes at the very far extension, there's another two holes closer up, and when you bolt all that stuff together, that makes a nice big box channel like all the hot rod guys like to do to their frames. Right there.
So Harold, I guess I'm a bit ignorant about this, but I guess you print in one kind of plastic, the green stuff as the supports, and then you print in your final plastic for the yellow?
In this case, they have it shown like that in the slicer, but no, I print everything together, same color plastic, except for that stuff you see in kind of the aqua teal color there. That stuff is printed. It's support, and it's printed very, very sparsely. So you go in there and you can rip it off almost. Well, this stuff's a little tough, and I printed it a little heavy, so I had to get some pliers out on it and some cutters. But that stuff comes off really quickly and easily compared to the stuff that's been fully entangled between the layers.
And the reason why you have support is basically when the 3D printer runs, basically all it does is it go here, over there, and back and forth. When the catch is, when it comes out with the nozzle is soft, but the key is you really don't want to have soft stuff all the way over here. Otherwise, it'll droop down as it gets hard. So what you do is you basically build rafters to support it while it's in the soft state.
This is
until it gets hard enough to support.
Another way to think of it is you can't print in air.
Yeah, gravity's your enemy. So let me explain just a little bit. Let me explain a little bit why it's printed sideways. I could get a much nicer print out of this if I rotated the whole thing 90 degrees counterclockwise. The reason they printed it that way, if you look, we slice horizontally. So if I were to turn it 90 degrees clockwise on that, all of my layers would be horizontal where all the force is going to be attached to. Because we printed it the way it is, those force is going against a flat layer that should not be breaking apart on itself.
See, Harold, this is exactly why the first time you guys almost got me into the cult was when someone mentioned that nylon was the same in every direction.
You can do it.
So like in this guy, the way this is printed, the weak way would be is if you wanted to let's see. Now, that's pretty strong in all directions the way they print it.
I will tell you, my new favorite thing is right there with those heat set brass thread inserts. It's my new favorite thing when it comes to this.
Yes.
Yeah.
The guys at work across the hall from me have this great big 3D printer. I mean, a huge thing in its own great big cabinet. And what they do is they do 3D scans of fossils, bones and such, and then they print out models of those so that the researchers are not handling the actual 250 million year old bones. And the way I've just seen them run it, I've never asked any questions, but basically when they're done, they've got this big bed of powder. And they reach down in that powder and pull this part out. I think.
They got one of those.
The resin printer.
They got one of those things. Is this HP printer by any means?
I have no idea. They actually managed to get a hold of and scan the fossils from Lucy.
Those printers are fantastic. The cheapest one I know of is about $350,000 to get started. And what they do,
that sounds like this group.
That's what they do is they lay down, much like a toner in a laser printer. They will lay down a very thin particle of stuff, and it's all the same stuff. And then they'll go back over that and infuse that, and they'll lay down another thing. So you don't have to worry about support, because the support is all that powder in there.
They're actually hardening the.
Yes, they harden it off. Then they have to let it cool, and they gotta make it off a little bit. And then you have this fantastic part.
And then you literally burn out the stuff that glues it together.
Yeah, and it's a fantastic system of doing it. And there's even people out there like Mikaki who do this one that you have a 65,000 color palette because of the way they do the particles. So you'll get full color models off of this thing without a retouch. I saw it a couple of years ago at a show, and it was amazing.
Assuming you don't have that machine, there are companies out there that will, for a price, print and do it in metal using that technique.
And John, I like the idea that they do instant quoting, so you can basically, using their online service, send them a file of some kind, and they'll give you a quote, which is pretty cool.
So it's not as cheap as actually own the machine.
Again, Murray, that's great, but you, like I say, before you send off to these guys, you'd make it in plastic and say, okay, this is cool. This is absolutely what I want. Then you send it off to them.
Well, you have the STL file or whatever. I think in their case STL. But here's an example of something like what's done.
Yeah.
You know, so you can get shapes like that, and it can be basically metal. I mean, it's effectively almost casting. The only thing is there.
Can you imagine CNC?
Right.
It would be very expensive.
Well, I've a couple of years back, I wouldn't say a year or two back, somebody had printed one and had a service to print, and I was going to say it was like $70, $80 for a small part, you know, not quite that big, in other words. So you would just have to create the file and send it off and see.
But David, there's one advantage though, David, is that as we've all talked about, the CNC is going to be hours and cost and machine cost and all that, whereas these 3D printed metals use, like, I think it's an aluminum powder or something like that. The cost of printing something would be, I would think, considerably lower than CNCing it.
On those powders, on those powder
resins. What these guys across the hall can do, they can take an old, say, a crushed dinosaur skull, and then they have this fancy little rotating platform where they do the 3D scan, and then they go in software and uncrush the thing, and then print the 3D model. And sometimes that's an iterative process that requires them to print a number of models before they really can get it right, because, you know, they're doing a lot of guessing. But their end results are really quite stunning. The level of detail and so forth is just astounding.
And that powder stuff, the stuff that does not get hardened, it's like a 90% reuse of that. So it's pretty efficient on all the materials they're using. So as long as it's not getting hardened, they can probably reuse that stuff too.
Well, that's interesting. I was up there late working one night. I caught the guy across the hall vacuuming out the 3D printer. He said it had just been too long since he'd done it, so I guess that was getting old.
Yeah. Those are fantastic printers.
Hey, Marie, the Xometry site looks really promising. I don't know what they charge for a piece, but the fact that they do all sorts of plastics and a number of different metals, and they'll let you quote before you make a commitment, sounds pretty cool.
Yeah, and there's several out there. I just happened. This was first on the list, so.
All right, well, that's an option too, because the idea of spending $1,000 or $1,500 for a machine I'm only going to use a few times, I don't know how often, is kind of a big investment here. You know, things cost a lot here.
They have so they may give you more info on the 3D printing aspects. Yeah.
But I do take Doug's and other advice on the fact that that first time it might not be right, and then you got this investment. So I could, over and over and iteratively get towards a design I was happy with.
Basically, it's rule of 3.
You could probably pay that $200 off pretty quick.
Yeah. I've got to take off, guys, but
We appear to be leaking users here, guys.
Okay. All right.
have a good one.
See you next week. Yeah.
Okay.
Yeah.
So y'all take care.
Okay, John, you're gonna finish it up.
Well, Harold, has you stopped the recording?
No, I haven't stopped it yet, but I'll let whoever edits out all our crazy stuff. Whatever.
I assume you, Doug, you'll get it from him, right?
Yeah, Harold, if you can just send it to me. You know my email.
Yeah, I've got
address.
an email address around here for you somewhere. We've done this before. I think it's president at whatever or something at whatever or treasurer at whatever.
Yeah, just have it on your iDrive or whatever.
I'll put it on the OneDrive and you can go pull it down, whatever you like.
Yeah.
Not a problem.
Sounds good. All right, bye guys.
Until next week.
All right, I'm stopping
now.
recording.
Thank you.
Somebody's going to need to grab the chat log though.